chaos breaks loose. I should not curse within the first few seconds. I don't know if there's still murmurs of that algorithmic mess of having curse words at the beginning of your YouTube video. Auto find and activate. Dun, 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 dun. And there is YouTube chat integrated with Twitch chat. Don't tell the Twitch admins, they get a little weird about it. And they have very weird ideas about what you can do with your chat. Like, you can't have Twitch chat intermingle with a YouTube chat, which is nonsensical to me. It doesn't make any sense why that would be a policy. They say it ruins your experience. But I think they don't really vet some of their ideas out enough, because it's stupid. But as long as I got a big stinky logo next to the name, I think I'm okay. And if enough people do it, they certainly aren't gonna ban everybody. If I get banned, it's not as good of an outcome for me. If I get banned because of something I build, that's much better for me, because then I can complain about being slighted by the Twitch admins for something I built, and that gets my brand out. Normal streamers, they get banned and, you know, they have to appeal to a higher power. Big streamers get banned, their numbers like triple, just because if they said something controversial. For makers and crafting, it's got to be something that we did relevant to our channel, getting us banned for reasons that are unjust, and then it'll be a huge boon to the channel and I get a week off. That's the cold calculus of streaming, the cold calculus of Twitch and being banned. And I am not a racist. I am not a horrible homophobe. I'm not a terrible person. I'm a nice guy, which does not work in my favor for some reason. In terms of getting one of those special bans that gets you made on Twitch, gets you enough viewers to make a career. I don't have that in my personality. I'm not loud. I am not, you know. All I got is charisma, folks. That's all you get here. Maybe today's title will get us a few more viewers on YouTube. It's possible putting live stream in the title will insulate me from people coming in and thinking that I'm doing a tutorial. That's my main thought about that. This is the 9-year-old Yacht Rock remix from Space Cowboys. I'm playing it because this audio channel does not go to the VOD, and it does not go to YouTube. YouTube also records at the same time. Twitch only records everything but that audio channel. Basically, I just have OBS throwing the audio out, and on the Rodecaster, where's the, on the Rodecaster, I have everything but desktop going to monitor and output. That's on desktop audio. Desktop audio is what is, what am I saying? Desktop audio is where the music is coming from. That's, you know, my browser window. That's why I don't have, when we pull up a video or something, you know, we never get audio on it, which is unfortunate because there are some industrial videos that have some hilarious music in the background. Just be careful not to build something so wild that the FBI says hello. Yeah, I used to know those guys. I used to know those guys. Yeah, it's just PC audio is just... So if you're on Twitch, or sorry, if you're on YouTube and it seems like I'm going insane and singing along to music that's not there, I can assure you that it is. Maybe if you listen to my audio very carefully, you might be able to hear my crappy monitors. My good monitors are on the gaming PC, but the M Audio monitors that were on some kind of a sale thing 15 years ago. What up, here? Sorry. What up, Herr Bothan? Haha, my voice. It is returned after a horrible sound was emitted from it. What's up, Colin Gate? Octano. What is that? Oh, it's a Kirby. Okay. Sorry, it's like super small on my screen. I really need this to make emotes much larger. But this is Social Stream Blade, and I set it up a long time ago. I don't remember what all the settings are on it, so I really needed to get rid of like the timestamp and everything. Actually, the problem is the timestamp helps me The timestamp helps me because people will come into my channel, leave a comment, and I won't see it. See, it's even larger on this screen. Jeez. People will come in and like leave a comment, and then it'll go away, and I won't notice it, and I'll come back to my computer, and I'm like, oh, somebody said something. I'll respond to it for a third time. And then I look over at the time, it's like 12:39, and the comment was left at like 10 o'clock in the morning. It's like, oh, okay, it's just been hours. I should stop reading that comment over and over again. So the timestamp does help me with that. The sort of, what is it? The dementia of streaming. Whoa. Picture in a picture. Have you ever done this with a camcorder? If you have, then you probably should schedule a colonoscopy. If you've done it with a webcam, then you're probably not as old as we are. That was we used to take the camcorder and plug it into the TV and then play with the infinity picture. Luckily, that's a shared generational experience. Point your phone at your phone. Have people done that with like FaceTime? Point your phone at your phone and look at the infinity phone? Because if you're doing that, then you're involving tens of thousands of miles of telecom communication equipment in order to send video out and then back in. That would be wild. Probably been done. Jojo in your burr. So OpenFFB I've been looking into, and I don't know if they're the only name in the game of open source force feedback controllers, but in lieu of getting their board from Germany, I bought a very similar ST Micro platform with the 100 pin chip. That's a lot of pins. This thing is a goddamn computer. Oh no, I cursed. Oh, it's okay. It's more than 30 seconds into the video, I guess. Look at the size of that thing. I can't even get the whole thing on the microscope at once. STM32 407ZG. It's this enormous chip, and this one is 1 megabyte of memory. A megabyte. That's insane. But I've got to set it up for OpenFFB. I've got to look at how OpenFFB was programmed and set this thing up for it, and then figure out what the pinout's going to be. Because I got a lot more pins than actual OpenFFB. But the whole project's on GitHub, so I should be able to modify it, but it's going to be in the ST environment, which I really don't look forward to doing. But this would be doing OpenFFB, and it would be another USB accessory. And then this would... I would need to bring in the braking resistor, the motor controller, the high current motor controller from Granite Devices, and somehow... because it's a card format for that thing. It's like a card that plugs into a card slot. So I'd either need like a breakout for a card slot or something, because this will be able to talk to Granite Devices. OpenFFB works with Granite Devices, motion control. So, man, all that for just the steering wheel. But I guess it could expand it at some point. I could use the larger controller to do like feedback joysticks and stuff. I don't know if I'll get around to that, but first make it work. First make it work. Got to keep reminding ourselves, first make it work. First make it work. Make it do work. Yeah, I don't have a lot of room to exist here. Of course, the whole simulation thing can push against the wall. I need to spend a little bit of time with Burn the Subs too. We need to desolder a whole bunch of wires, and I need to start making a wiring harness for it now that we've got all the other improvements on there. I need to start connecting things. That's one thing we haven't done. I also need to do some sponsorship stuff so that I can keep my copy of Fusion. I don't know where I am with the licensing. I haven't communicated with them in a while, and I don't know, I did 2 of the things like a month or 2 ago, so maybe I am credited until the end of probably next month. But I don't want to take any chances, and we've got plenty of stuff to design. We need to get all of these stalks together. It's botherback. Yeah, it has a weird, unflattering camera angle that shows the simulation stuff. And the panel that I put in front of my computer, we did all that computer building. I put that panel in front of it because sunlight gets onto the computer towards the evening. There's a big beamus of light that gets into that window, and it cascades across, and sometimes it'll catch stuff on my desk, because that's my computer desk that you can't see anything on it. It'll cascade onto the computer desk. I'm like, hit something reflective and just completely blind me. So I put that panel up there so that the sunlight doesn't cause algae to grow in the computer's internals. I need to add that giant reservoir because you can't see it in this camera angle, but there is a clear tube that goes between the two radiators. And that clear tube fills up with a giant bubble. And there's a giant bubble in it right now, and it's unnerving to see air, that much air in your water lines. But the pump isn't pumping strong enough to move that air into the pump housing. That pump housing really needs to be down low, and there needs to be a reservoir up high. And that way it won't be that big of a deal when air collects there. But properly designing a water cooling system is so much of a pain in the ass that a lot of people don't do it. And you're better for it, better for not bothering and just air cooling, because it's safer and easier and you can replace parts more easily. I did it because I wanted that computer to last in perpetuity, and it seems to be pretty stable. It's better than my streaming computer. Those that didn't hear, streaming computer, I was going to start much earlier. I was going to start at noon, but because, you know, I ate lunch and I was like, well, what else am I doing? I'm thinking about what I'm going to do with this microcontroller. You can get UV tubes for aquariums. That's 6mm ID, 8mm OD, and 12 volt for the water control. Oh, that's pretty cool. UV tubes, yeah. I hear that's bad for fish. Obviously, it's fine for the cooling system, but for the fish, it like over sterilizes the water. I have heard of those. How much do they cost? What do they cost? I don't think I'm going to be incorporating that into my water system, but it would prevent algae. Another thing you can do is put just like 1 or 2 drops of bleach in there. Just make it a little bit bleachier than it already is. But it's too much bleach, bad for the plastic. The plastic can tend to harden with the wrong stuff in there. I was going to put alcohol in, but apparently that's really bad for the acrylic. Walking in the park and reminiscing. UV filter? No, that's going to pull up like glass. Oh no, that's going to pull up exactly the right thing. I would imagine having something like this would be a lot for a water cooling system. It could double as an extremely expensive reservoir. What the hell? Limited time deal, only $300. I guess these are the smaller ones. No, that's a lens. 150. These are for like swimming pools. UV filter aquarium. Yeah, these are the $30. That's a little bit more reasonable. $40 for something like that. And it's got a pump on it already. That's kind of cool. Burn the subs, the wall-mounted sub-burning system that we will build. I will get back to it. I'm sorry that it's been plaguing this channel for years and I'm totally burnt out on it. But we'll get back to it because we need to integrate some of the systems together, and then we need to figure out what's going to power the brain for Burn the Subs. But Burn the Subs also has a water cooling system just for fun. We soldered a bunch of brass tubes together in order to make a distributor, and it's got an old reservoir that fits in a 5 1/4 drive bay up top. And then we took an old water cooling pump and hooked that up. That was fun. I am currently in some such stage of burnout trying to wall mount my PC. That was a big AutoCAD project that we had where I was designing stuff that would fit my computer parts to a wall control panel. Wall control panel, barely enough room for everything, even though it's much larger than the case I have currently, and it would showcase all the stuff. But we got kind of caught up making everything sort of make sense. I'd rather use engine coolant, as that is algicide without ion pullers. Interesting. I used to put water wetter in my water-cooled computer back in the early 2000s, 2002, 2004. Water wetter was interesting because my old water cooling setup didn't have a reservoir, and I didn't think anything of it. And it turns out, back in that day, water tends to expand quite a bit when it gets warm in a system like that, and it tended to get pretty warm in that system. I had, not enough radiator. And the fact is they didn't have as good of an ecosystem of water cooling stuff. We were using PVC tube, and I would look at my computer after running it for a while. The tubes, you couldn't pinch them. There was so much water pressure in it, and it actually cracked my water block. I had one of those spiral water blocks. It's just basically a chunk of copper with a spiral on it. They didn't do micro fins back then. It was just a spiral sort of trough for water to go through. I would wake up to my computer screen in college. I would wake up to the computer screen looking like a Nintendo that you had to like blow on in order to get it working, like blocks of color and stuff. Open up the computer, water block cracked, dripping water wetter onto the graphics card. The graphics card had evaporated the water wetter with heat, and so there was like a gel left behind. It was like soap. And I went to the men's bathroom in the dorm, and I took a toothbrush and I just kind of scrubbed it off and then peeled off what I could and scrubbed it a little bit and blotted it with paper towel. I plugged it back in, it worked. It worked. It didn't break the card, which is shocking. Whatever the hell was in that stuff. I was like, oh yeah, water wetter will definitely make it work better. It'll pull more heat out because it'll be like water but better. No. No, it barely does anything. I don't think it does anything. I think the only reason you would use something like that is to keep, again, algae out of a system. Because it's just like it's like whatever, dude. All right, let's start up Arduino. Let's get that going. I don't know how much progress I lost. I know I've been hitting save a lot on the Arduino though. Yeah, that's true. It may have prevented the water from conducting on something as sensitive as the opposite side of the circuit board of a GPU. Newer version? No. Bow, bow, bow. Sorry, there's music on the Twitch side. We have a lot of pins on this thing. This is a 64-pin device, and 63 of the pins have been used for this. Let's get the drawing in here. Open. Oh no, that's just right here. Oh no, it's not. Yeah, open. I've been saving this one a lot too, so Control S is your friend. So we need to go and get a library for the Arduino that's going to run this keypad matrix and get all our variables in there so that we can actually, on the serial print, see when we hit any of these buttons. And then we're going to get to the mux. The mux is just a 74HC4051, which is a 7400 series mux, and it's connected to 7 analog devices. That would be 6 knobs here and then the crossfader. And if we can get this thing to realize when there is a change, when something is being pushed or when something is being twiddled like a knob, we can have it then output CANbus instead of doing serial prints. That's sort of the idea here. I suggest you move your pins to a header file. It's easier to Alt+2 to change pages. That's true. Having a header pin file would not be a bad idea. I'm going to keep it all in one big program right now just because I'm fleshing out the disgusting, horrible skeleton of what's going to be the CANbus running stuff. But having just a separate tab that's called in like right here and have all this go to a different page, that's not bad. That's actually a really good idea. Maybe I'll do it at some point soon. Maybe when we get a little bit overwhelmed. But for right now, I've just got all the inputs in here at once because we're also going to need variables too. I'm going to need basically a table full of analog definitions here. But we'll do that with the matrix library. I'm gonna have to keep that feather in my cap. I'm gonna have to remember that. Join the Twitch party. We have music. This is what Twitch wants to prevent. They want to keep you guys separate. They don't want these chatters to be able to talk to one another. Hey there, YouTuber. I'm from Twitch. Get that guy. Get him. Throw him out. Guards. I don't know why they're like that. Why do they think it's stupid? It's stupid. I don't agree with it. Now you can chat wherever you want. You're totally fine. You're totally fine. You're just missing out on a groove. I'm gonna get the music out of here in just a second anyway. I'm feeling programmally today. It's cold out, so I don't feel like going out. Although I did take the dog on a long walk already. She had a long walk. She got to see all kinds of friends out there. I'm going to chat from both places. That's illegal. That's illegal. That's against the law. You cannot do that. You can't. You can't. You're risking my channel, my brand of Twitch. You can't. You just can't. And Discord. So I played around with the Discord API a long time ago. That was back when OctaveJ was still here. It was so long ago. And since then, he's gotten a life and gotten married and moved to America and become an American citizen. So a little bit of time has passed. Anyway, so back in the day, we tried to get the Twitch API running so that we could have a little bar of lights right by the camera, so that if I forgot to do something like change a scene or something, Discord admin could send a command and it would make that thing flash in my eyes really bright. Why are you not streaming on Discord too? I don't know, it's not really monetizable. I'd rather just people from Discord be here. There's a link, there's an announcement section that auto posts. Taco Bell acquired. I had Wendy's because I got, I was like, chicken strips, I'll try them. And so I ate one of them and I went, I don't want these. And so they sat for a while, basically 24 hours until lunch today. And I threw them in a tortilla with sriracha and stuff and ate that. And that Wendy's grease, I don't know about that Wendy's grease. I don't think I like it. Taco Bell chicken nuggets. What? You're just saying chicken nuggets into my chat. You guys just do that? You just come into somebody's chat and say chicken nuggets? Why would you do such a thing? Why would you do that to me? What did I do to you? Anyway, so I had a chicken strip wrap, not the one that you can buy. I made my own, and it was revolting. It was revolting. It was really gross. Like, it's not that bad, but it just tastes really cheap. Like, the chicken's good, but the grease is just, it's too much. It's too much, too heavy. I'm gonna have like the worst heartburn. A 3-stream streak. Why does it come in this order though? 350. Who cares? Don't put 350 watch streak with no space. A 350 stream watch streak. It's a 3-stream watch streak because it does say over here. I had like a 100 watch streak for Rabaz, which I don't know if that's not really something to be proud of. It's not. I don't like seeing that. I don't like it. I don't like it. It's like I think it was 90. It wasn't 100, but it was like it's your 92 stream streak, and I'm like, ooh, I don't know. I don't know. I don't think I want to know that. I don't think I want that information. I didn't know that this was an AVE sticker. I bought it at some point, like the day he showed it in there. You bot viewer. I'm not a bot. I'm a human being. I have a soul. My favorite Futurama line, look at me, I age. I'm not a robot, I age. You can just see the writers in the writing room going, what's the worst metric, the slowest metric to show that you're a human? And it's aging. All right, I gotta get the music out of here because I'm just gonna sit here and listen to this mix. It's a good mix. You guys should check it out. It's the Don't Stop the Yacht rock. Oh, that was a heady burp. That was a heady burp. I should probably take a heartburn med because I forgot to bring those upstairs. A famotidine. I've been taking this stuff religiously. Uncle Bumblefuck sticker. Yeah, you know, not as supportive of AVE after the pandemic. Plus, there's a phenomenon with AVE that I got a little bit sick of, where if you go to like his subreddit, because he's popular enough to have a subreddit, I'm not cool enough yet, or at all, or ever. I'm not cool enough to have a subreddit, but would it not irritate you if you had a subreddit where people were posting all sorts of interesting things in their lives that pertain to your stream, and they're all trying to mimic your unique-ish sort of Canada-ese, all of the AVE-isms, keep your stick on the ice and all that stuff, and they're just parroting you. I think that would be a little creepy. I don't know about that guy. So I try not to watch too many of those more popular and influential and successful people, lest I accidentally or intentionally or subconsciously, I was looking for that word, subconsciously mimic any of their behaviors. You guys, the comment yesterday was, you sound a lot like Rolf. And I'm like, that's my favorite Muppet since I was a little kid. Oh no. Have I accidentally made myself Rolf without realizing it? Do I have two human hands that come up from below that are oddly not connected to elbows at all? Do I sound like Jim Henson doing his little, the Jim Henson voice? I don't know about that. Yeah, so I try to stay away from other creators for that very reason. Roboz is safe because you guys, I'd be dead before I start going, yoo-hoo, hello everybody, welcome to my stream. You know? Okay, anyway. So we've got this this MIDI pad, kind of a cool little thing. Something I was looking for when I had my simulator set up that piss out my ass. Yeah, I don't have... Men vad far hette. Men vad far. Vet du, vad vet du? Back when I was doing simulator stuff that clipped onto the side of a desk, I figured that would be the best way to do it. It's a lot of fun. You clip the joysticks onto the side of the desk. Now has come a time when we are building a full-blown man-baby rig where I'm taking real car parts and I'm turning them into not a real car. Basically, my brother dropped off a seat. I had a wheel. I bought a steering column. I had real car pedals. I have a real car gas pedal. And with it, some other parts that have sort of accumulated over the years. My brother dropped off the shifter. I had this pad, which was supposed to go on the desk. I have multiple switch panels and stalks, all car parts, some simulator parts. And it's come time to take them all over because they are all discombobulated types of things. The stalks plug into a controller and they have different voltage levels for different positions. The MIDI pad plugs into USB. I'm gonna sneeze. Woo! That was a dad sneeze where you go, ah! That's a dad sneeze. Anyway, the pad plugs in with USB and speaks to like Ableton or something, right? The car parts all speak CANbus. The force feedback controller didn't have an external input for analog and buttons. Like it didn't, you weren't able to speak to the API because Granite Devices didn't program it. So the thought is, in order to unify all of these devices, I'm going to make them all speak CANbus. Because, you know, default CAN bus for the car parts, we might as well build up a bus and then I can plug the car parts in. And if I can get them into Node-RED with a Raspberry Pi, we can integrate them into all of my things that I let you guys control and things that I control in the shop. So I can make one of the buttons on this button pad turn on and off the light if I really want to. We started with this thing and we're basically building up a framework for a CAN bus device that's going to have its own address and it's going to be able to speak on the bus to everybody else. Fascinatingly, I thought I was going to be taking this thing over by soldering to the pins. Just take the microcontroller out, solder to the little tiny pins inside. Then we discovered that this thing has essentially what is a blue pill. Not like the incel thing, not like the Wachowskis, a blue pill named as such because they could make the circuit board blue. And because ST Microelectronics are a pill to program, the blue pill is an Arduino ST Micro. So they ported their core over to Arduino so that we can program these things in an environment that I'm more familiar with, because I'm dumb. Like, I'm not smart, okay? I'm just not. I'm not smart. I'm just motivated. I can program things in Arduino very comfortably. The ST Micro stuff scares the pants off of me. It's super weird, and it's like, I don't know. The Mutable Instruments synthesizers taught me a little bit of STM, and they were running a virtual machine that would program the ST Micro using its programmer, and it would compile it and use like Vim or whatever the fuck to no, I'm not doing it. I'm using Arduino to reprogram these things. Lucky for us, this thing had an ST Micro core, and ST Micro has the Arduino core. Turns out we can just throw code into this thing. So we took the pins external. I had to hook up a separate serial monitoring device, but with the pins external, that means we can throw code at it again and again and again. A little session of reverse engineering, and I had the entire schematic, including the fascinating tap pads, which are actually analog and not digital. The tap pads have this concave or convex button, and the harder you push it down, the more it shorts out a resistor. It starts by not shorting out a resistor very much, and so you get a weak pull-up, so that lowers your voltage raises your voltage from ground. And the more you press down, the more you're shorting out a resistor, the more 3 volts shows up. Very clever. The more 3 volts shows up. It's a similar thing that PlayStation does with their analogs. PlayStation analogs are that system realized. They're quite clever. Although PlayStation, it's a continual pad, and your button pressing down shorts out more of it. So you have a big fixed resistance, and then you start shorting out your resistor as you push the button down. Very clever. And we got this working, and we got this to serial print, and we got relevant values out of it. I'm not doing 0 to 1024 on this thing, even though the ST Micro can handle it, and it might be that for like music production. You'll have to excuse me, I am burping up hot lava. I should have realized that any form of fried chicken is anathema ahead of stream, and I'm probably going to stop eating lunch altogether. That'll make it much more stable. Much more stable for me talking to you guys. Whew. Anyway, yeah, so we don't need 1024 positions on a tap pad. I don't need 1024 positions on this knob here. I don't think I am gonna notice the difference between this position and this position. I did move it. If I was doing music production, maybe. I don't know about the AB encoder either. I guess it's gonna have to do individual packets per tick. Tick, 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 tick. I don't know how fast that's gonna be. That's gonna be like, all I have to do is this, and it just vomits a bunch of stuff onto the CANbus. I guess it'll be fast enough for it. It should, but we're moving towards getting a bus going that we can test with. We've got this thing on the bus. I need to install Node-RED into the Raspberry Pi, and then we can start messing around with it there. And I kind of want all my other accessories to follow. So this thing has been kind of fascinating. It's taken over stream for the past like 2 weeks, 3 weeks. This thing will speed to a halt soon. It's gonna get there very quickly. So what we're gonna do today is take a look at the Mux. Muxes are devices that allow you to flip switches using voltage. Using a binary number, you can flip to a switch. Muxes are basically designed to take a bunch of lines and put them on one line. That is Mux. So when you're muxing about, what you're doing is you're taking a bunch of inputs and you're putting it onto one line serially, sequentially, in order to get the data from those lines. And we have an analog mux, a CD4051 mux, and then we have an A, B, and C line. So A, B, and C are just a binary number from 0 to 8. I'll probably have to, I'll probably do a uint that we'll iterate through, and we'll put out on the A, B, and C lines, which is PD2, PD1, and PDO. But yeah, we'll put it out on that line, and then that'll flip us to one of the analog channels, and we'll have to see what the range of the analogs are. They've got, whoever designed a Samson, I want to talk to Samson. Samson put a stabilization capacitor on their lines. For the button pads, we got some pretty stable values between like 200 and 1,000. So between 200 and 1,000, we just scale that back to 0 to 255, and it'll remap it, and then we just put in something that keeps it from going negative. Now, I could use uints, and they'll just be a binary number from 0 to, 1054 or something like that. But I used ints. Ints take up a little bit more space in the memory. We have an STM32 F103. There's so much space in that fucking thing. There's so much space. I do not have to do UN8Ts to save space. What does this thing do? I used this in Star Citizen using a program called FreePie, I believe, and FreePie would just map it to a joystick, and so I was able to use it to turn on and off like lights. I mean, the labels are still here. Labels are still here. I've got G3 Avnix power. What? Gimbal lock, radar, couple aim move, generator power, computer power, landing mode, landing system landing. It's just spaceship stuff. Yeah, Star Citizen in particular has 1,000 buttons that you can use. Now, the buttons and switches, I don't know if I'll have a use for them in every game. I don't think I will. But I have them, and I can make them do more than just game buttons. I can make a button do something in the physical world. So... Oh, doesn't need a billion buttons, but it helps. Yeah, you can click stuff with the mouse, or you can have buttons assigned. So, a tap pad. I don't know why I would need to press the button more, but I have the availability. I have the option to do that if I really need it. I could make something in the simulator respond to how hard I tap the button, and we can do that in Node-RED. That's the idea. The idea is that I pull everything in Node-RED, and then I have spaghetti in Node-RED. And Node-RED, I can make toggles and scale things, and then I'll spit it back out into an HID device. So I'll have multiple joysticks that I can communicate to the computer with, or I could have it do something else in Node-RED. It could talk to MQTT, it could trigger something in the real life, in the real world. Is this real? Is this the real world? But yeah, I'll have that availability. But the point is that I'll have the option to do all this stuff. So anyway, we got to do muxing. We got to do muxing. The mux is used to get to all of these analog inputs, including the crossfaders. 7 analog inputs, 6 knobs, and 1 crossfader. So we're going to see if we can, just from the pinout that I determined, get this to work. Now, the keys will be quite cool. Laugh track. This is where the laugh. Does somebody have... Is the guy in the booth? Can we get the laugh track? Okay, there's nobody in the booth. There's no booth even. I don't have somebody in the booth doing production. It would be more insulting if there was a laugh track. I have a couple more of those funny noisemakers, and I think a laugh track was one of them. I should probably hook that up so that you guys can play channel points and put a laugh track in. That would be so disruptive though. Like if something serious happens and then you guys set off a laugh track. That actually sounds pretty decently funny, to be honest. Okay, anyway, yeah, they've got 150 ohm resistors on the top and bottom of this. I guess just maybe to make sure that you're not pumping too much current into your microcontroller. We're gonna have to see what values the microcontroller sees, and that's where serial prints are gonna be important. There's probably a library for muxes, isn't there? So mux ABC and output, those are these pins. So ABC and output, so what we're gonna do is we are going to initialize the mux. Let's take a look at init mux. Oh, we can pack serial into there. And we're gonna keep that analog test going, but I'm gonna take this. Let's see, we'll take this into serial, init serial. Just so our main is, our setup and our loop are more simple. Now that we've gotten it working. Okay, init mux, output, input. Okay, so then we're gonna run that. So we've got our outs and our ins set up here. In the loop, let's see, test LEDs, analog test, digital write. So let's do mux. All right, so we'll just put that in our loop functions. Void do mux. So the debate is, how do we go through all this stuff? Do I I mean, in one instant, scan all of these analogs, scan all the button inputs, scan the matrix. Is that going to be fast enough? Not even a please do, Mux. No, we need to be polite but forceful. Polite but insistent. Scan these things, scan these things, scan these things. That takes time, and it might be more equitable to set up like a timer to go to the next thing. Because if we're scanning these analogs, I've moved teams, welcome to Twitch. Oh, we're poaching Twitch viewers from the YouTube channel, huh? Or poaching YouTube viewers for the Twitch. There we go, that's the way. That's the direction. Now I have one viewer on YouTube. That's okay. First time chatter too. We gotcha. There's no music right now. I stopped the music. Or did I? Yes, I did. Yeah, that's so. Have it run a timer where it'll look at a different input each time so that we can stabilize the voltage on that line. Because when you switch to something, it's going to make stuff kind of wobble around. Let's start by just scanning through all of them. And then if that doesn't work out, we can put a timer on the mux moving to the next thing. I know you. I know, but it still gave you a little first time chatting thing, which is fun. Do mux, so timer could go here for stable read. So it would be, we need 7 variables, so E1, E2, E3. So variables all the way up here, we're gonna make them int. I think we're gonna make them int. Do I do them with a define, or should I make them in a table? And then if it is a table of values, we can look to see if any of the values have changed, and then we can use that in our iterations. Oh, decisions. Probably should be. So int knobs. And it's going to be a table. And that table is going to have all these things. And then it's going to be E1, E2, E3, E4, E5, and then E6, and then fader. We don't need to make it a big deal. And then, do we need, yeah, I need a semicolon at the end of that. And then constant int is the length of our knob length, which is 1, 2, 3, 4, oh yeah, 7 entries. As you're already using C++, a struct would allow easy library creation. Yeah, but I barely understand structs. I barely understand structs, and if I did a structure for that, then I could have like a part of it be like, has it changed significantly? Because we do need something to check to see if it's changed significantly, because we don't want to be belching out packets too much. If the thing is sitting still, I don't want it to be using up bandwidth on my CANbus until I start twiddling its knobs. So let's see. So right now, what I'll do is I will set something up to scan through all 8 of its states and plug it into these variables. And then if the variable is different, we'll print it out. And I guess, could I call on the variable name in order to print it? I think I might be able to. So 0 to 6 is going to be knob length, and that is a constant integer. But I might need that to actually, I might need an iteration variable that's global, because we might release the program to do other stuff while we wait for the analog thing to stabilize. So I think I'm going to do int knob last, knobless. Take that and go back down. Go back down to our dungeon, our programming dungeon, all the way down here. Where's our dungeon? Those are initializations. It's grid, CANbus, encoder. Oh, and then the accursed system clock. I don't know how any of this crap works. Knob length is equal to knob length plus 1.5. Huh? Oh no, you know what? I can't. Wait. If I'm initializing it with these variables, those aren't ints. So that actually has to be. Yeah, that's not gonna cut it. Yeah, exactly. Oh, that sums up all coding. Well, for me, it's the it's just what that clock stuff is. It's the weird stuff that scared everybody away from microcontrollers. 1, 2, 3. Sorry, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7. Excuse me. Because this will store the values of the knobs, not the identity of the knobs. We'll just have 0 to 7 here. That's just, they'll just be numbered. We'll know what they are. We'll know personally what they are. This is too confusing. Move that over. We don't even need to really look at that. We actually don't. I don't need that. I'll just put the schematic in the background over there, and then we get back to our stuff here. So we have the here analog variables. And yeah, I think that's all we're going to need. So I'm just going to grab those variable names so I don't forget them and go all the way down here to do mux. Do mux. Do mux. Do mas. Do mux. All right, so we'll start off with just a for loop. For I is equal to knob len, I is greater than 0. Greater than or equal to? No, we're going to do it greater than 0 because even though I could go into the negatives for ints, I'm going to try to keep it just in case it's just something that's this is deep habits. It's just habits that I cannot violate, which is thinking about all of these as just binary numbers. Because that's all they are in the microcontroller's memory. If we were doing like an AT-tiny 85, then I might want to store everything as an unsigned integer. If I'm calling them as ints because we've got like a whole goddamn megabyte of memory on this thing, they can go into the negatives, but in my iteration, I don't like to allow that to happen. So if I'm counting down a variable, because I like doing things from big to small. We like I minus minus, even though it's only very slightly faster than I plus plus, we use I minus minus. I think they got it down to like a microsecond faster, which in microcontrollers, I guess that could be a lot. For this microcontroller, it does not matter. So the things that I'm doing in here, the habits that I'm using, this is just stuff that I'm used to. And I'm doing stuff that I'm used to so that when it all goes wrong, I'll know where sort of I'll have an intuition on why stuff went wrong. Yeah, we're gonna iterate through the array using the numbers to scan the analog pins. So I think I need an array of pins. So int. Oh wait, this is in do mux. I gotta make sure that I'm not. I'm just putting these here to remind me of the variables that I've created, so I don't have to go all the way to the front of the program again, even though it's like right here. Where are we? We need int knob pins is equal to, and then it's It has not been defined yet. Oh wait, because those don't, it's just mux 0. Oh yeah, we're just the mux input. That's right. Okay. Sorry. I never said, listen, I said that this is a live stream in the YouTube title because I got one comment historically that it was the worst tutorial ever on a video where we were just hanging out and taking something apart. By the way, I bought the lock cylinder for a VW. Haha, so they can use the switchblade key. So at some point, we're gonna have to get into keylock, Keeloq, and figure out what VW's internal things are. Basically do that breaking into a car thing that got everybody's knickers in a bunch. We're gonna do that so that I can walk up to my setup and hit unlock, and it'll go wook wook and unlock. Because that's the first thing anyone's gonna want from my simulator setup. It's the first thing. So that's going to be some comprehensive hacking coming out of our corner of the internet, I guess. And oh, in addition to buying the lock cylinder, I also bought the headlight switch for an F10 BMW. I thought it was the better looking of them. So I bought the BMW switch to turn on the headlights. It was $25. This is $28 for the lock cylinder. I got the whole lock cylinder, including the switch at the end. We're gonna have to see what mechanism is supposed to lock the wheel. It would be very funny if this wheel locked too until you turn the key. Turn the key to start the simulator software. Tempting, and I could, but my summer car has button inputs for the on position and start. So at least in my summer car, that would not be for starting the system. We're also going to have to make a big ass emergency stop button too, just in case this thing folds me into a pretzel. Keyless entry. No, I got a whole ass lock cylinder. I think that gets here today. That actually shipped really fast. Okay, so we can just count. We can just count through this because we have our variables for the pins. If we count, we're sending it to mux A, B, and C, and that's what's going to activate. We're not looking for a pin number. We are simply sending mux 0, 1, and 2. And listen, I've said it before and I'll say it again, I'm dumb. I am so dumb that we are going to be doing the bit reads, or the bit sets. Not bit set, we're gonna do, what are we gonna do? Actually, I can just use the number, can't I? I was gonna use some of the bitwise things here, but what we can do is we can have a uint4t variable if we want as knob last, but knob last int, I'll just keep it as an int. I'll keep it as an int. Yeah, I have to recharge the battery to open the door to the simulator. I had my VW for many years and I never had to recharge the key, but I think at least in the BMW had both a thing that read a code from your key and recharged the key. So when you put your key into the car, it would recharge the key. So you wouldn't have to replace a battery. There's no LED on the outside of this thing. I think it might use, oh yeah, the emergency has been completely, that used to say emergency on it. That's what would set off your car alarm. I don't think that car is anywhere near us right now. I'm gonna press it. I pressed it. Oh my God. Oh wait, do I hear a car alarm? Yeah, so this, it may have a rechargeable battery in it. And the key, the cylinder that I got has that little piece on the end. There's a little like piece of black plastic that has a whole bunch of pins coming out of it. And I think that might be for both recharging the key and for reading its secret code that'll unlock your car. So it's possible we could be implementing the whole system. It didn't recharge it, it just provided wireless power and the wireless side woke up on its own. What, like when it charges, it wakes up? I don't know what VW uses, so they could be doing anything, man. I'll have to look into it. There's probably some tutorials. So this would just power, and then this would wirelessly communicate with the rest of the car, or at least that's what BMW did. VW probably doing something very similar. But that makes more sense than having a separate transmission path. That makes more sense, component-wise, too. Okay, so I'm just trying to wrap my brain around this. So we are going to iterate through knob length. And so to begin, we'll just do knob length down to 0. As long as it's greater than 0, and then it's, yeah, the thing minus, sorry, I'm trying to find my place. Here we go. Knob length, I is greater than 0, I minus minus. And then, let's see, we're iterating through that. And then for that, we analog read, rather, knob of I minus 1 is equal to the analog read of, wait, that's wrong. Well, mux 0. Or mux out, it's an O. It's an O, it's not a 0, it means out. Of muxo! But we need to set the set pins and then read. So we set the pins, and so digital write mux A, mux B, mux C with a bit read. So I'm not going to do the bit shifting. The bit shifting confuses me sometimes. I know how to do it, and I took many classes in bit math and how bit math functions. And I know you're going to turn your nose up because I can just do greater than, shift it over 0, 1, 2, and 3 times, and then use that bit. I'm just going to bit read, which does it anyway. It just does it a little cleaner. So we're going to bit read knob len. Knob length is an integer. Maybe we should make it a UN8T. Probably should make it a UN8T. Oh yeah, it's not. No, we're bit reading I. Bit reading I. Bit read I of, and then what's the order going to be? And this is going to be a UN8TI, which just means it's a binary number. A nice clean binary number that we're going to start at 7. A nice clean 7. 7 is not a clean number. Knob last is for the next time we iterate, but bit read of I, and then bit read of I, and then I got to figure out what order 0 through 7 is so that we're iterating the right stuff. Now I could just program this off the cuff. I could just program this off the cuff and then take a look at what we get out of the serial prints. That's one way to do it. And then I can rearrange it to order it properly. I just want to see the power of my own schematic here. So A, B, and C, what is the order? Well, I'm guessing, well, I don't know. I don't know what order. So CD 4051, we need that data sheet just to figure out what the order of the switches is. CD 4051 data chart PDF. Ah, no AI this time, huh, Google? You don't got nothing to say. Oh, look at that. They have it nice and conveniently for all of the dumb people. Instead of just telling us what it is, they just put the binary number. Oh, that's nice. That's nice for us. So it is CBA. So bit read of position. We're going to go in 0, 0, 1, 2, I think is what we're going to do. So 0, oops, that was a tab. 2. Okay, the seltzer bottle right next to the keyboard is really messing with me because my hand's like butted against it. When you working in like on a shop computer is always a little bit weird. So we set the pins, we read the analog read, and then we put it away. Oh no, we're putting it away at the same time. Right. And that's gonna go very quickly. We'll start with it being very quick. So, let's see. We don't have a last value. Actually, we do have a last value. But we would be better to check it first and punch it into a variable instead of doing this directly, because we still have to scale it. But for right now, what we'll do is a serial print line. So this is very fast. So serial print, and then we're going to do I. This is going to print every single one. It's 0 through 7, 0 through 7, 0 through 7. So I guess that's okay. And then we'll put a colon space. And then print line. Just so we know what our variables come in as. Knob of, not in quotes, I minus 1. Bracket. Bracket. Yeah, it's stuff.print. Yep. Correct. Because we're using the USB pins with software serial. Oh, you mean like powers like an RFID tag? I thought it would just tell it to transmit like an unlock or something. Yeah, I don't know. We'll see. What is up, Madam U? We are sitting here and we are programming microcontrollers. What is INH? INH. Because it's A, B, and C. I don't know about that one. We don't have that. INH, VEE, VSS, AB. Common Y out. INH. What is an H? High or low? Harmonic distortion. Oh my God. What is all this crap? Let's see. Yeah, there's a turn on and turn off time for it. We're just gonna run it balls to the wall at first, and then we'll try to incorporate something. The help flag. It's a disable? Oh, okay. Chip enable. VDD, VSS, VDD. Nothing about NH on these. All right, let's not get dragged down by that. All right, so this I think is ready for a test. It's really gonna puke a lot of stuff out on serial. The inhibit bit. Oh, okay. This is weird that they tied it to the switch bar, but I guess it disconnects the whole thing. Inhibit. Oh. Well, hibbity jibbity. Let's see. Print line. Print line. Analog read of mux out for knob I through whatever, and then it's going to print that, which will take a little bit, and then it'll come back to this. So this will be puking out I is equal to 0 to 7 is equal to value, and the values will probably be to 1024, but we'll see. We're making sure that we get all the values and that they change when I tootle my knobs, and that the one that we think is tootling is the one that's tootling. So I need to just plug this thing in to Hair Programmer. That, which fell out. So we're using SWDIO to program using a knockoff ST microelectronics dongle, because that's what was available to us on the pins of this thing. We're keeping all of our old code, so if I hit any of the buttons, they will light up. And let's just see what happens. So upload. Tut tut indeed. You know I can't just let that innuendo hang. Oh, semicolons. It's gonna trip up and then tell me what I already know. There's no way that it lets me upload this without semicolons. Yeah, there we go. Everything else looks good. Just a simple iteration. All right, all right. Tick tock, tick tock. At 2:30, I gotta do a couple food things and feed the dog. So I'm gonna do that. That'll just be a quick BRB though. Just gotta keep my eye on the clock. My poor dog needs food. Oh my God, the compiling. Our microcontroller code is extremely simple. So knob was not declared in this scope. Int knobs. Knob. Nog. Hey, Whoopi. Okay, where are we? I'm just looking for my stuff. There we are. Okay. So knobs, and then knobs. Knoblen is good. Mux is good. I print. We're all good. Okay. Upload. Try again. Oh my God, it takes forever. Our code is so simple. All this compiling for this seems like a waste. Oh, and my tabs are weird. No, they're not. They're actually, no, they're good. Because we can replace this for loop with a like an if statement, a couple if statements that'll basically just iterate through the numbers each loop of the program, instead of hanging up our program to scan all these. And then we can do one scan, let the program loop, and then come back to it, and it'll slow it down and give us better, more stable values. Dear God. There's, I guess, a lot of STM32 XPack ARM none weirdness. All of that for 5% of the program. Okay, so with that having been done, I can plug this into USB with our COM port thingy and make sure that the COM port is the same. Port COM8, okay? We can take a look. And oh my God. Okay, so we could try to stabilize this. I don't know if we can. So I think what I can do is I can put a bunch of blank lines at the bottom of this. So serial, or no, stuff, print line, like that. I think the serial reader will see a bunch of blank lines and help us out. Like that. I mean, interrupts, basically the reason that I'm saving these into an array is so that I can see whether or not the value's changed. And if the value's changed, then I can choose to print it. Yeah, that's coming. That's all in the future. We are going through this as if you guys were as dumb as I am. Didn't do a lot to stabilize it, did it? Timestamp is not helping. I can kind of see through that, but not much. Because it goes from 7 to 1, but that's not that stable. How do I stabilize this better? What's the size of my screen here? 1, 2, 3, 4. So put 4 more in here and maybe it'll make it a little bit better. Like that. Print FDDD. I guess I could do that too. Well, that didn't really work. I don't think we have a clear on this thing, do we? We just have the end of a thing. That one value is moving though. See, it goes up to 1,000. However, I don't think they're all coming in. Well, let's put them all at 1,000. Okay, well, those are all at 1,000 except for, do we have the crossfader in here? I don't see it. But 7 is E1, it seems. Or no, that was... Ugh, it's hard to see. How do we stabilize the serial print? Well, I could do the serial plotter. But I don't know if that sees the 7. Yeah, it's doing weird stuff. That's where they're all at 1,000. See, and that one's not coming through. That one's not coming through. It's only a couple of them that are working right now. But it's jumping between the values. You have to use like the wall thing in order to do the plotter. Hey, lines and squares, how you doing? If I made a wall in between them, well, how do you, if I don't do them on lines, and then I just give it wall, that might do it. That might do it in the serial plotter. The plotter. Unit Ti is equal to knob length. I is greater than 0, I minus minus. And that should be going through all of them. It's just some of them aren't giving me a value. We'll see if this cleans it up. I hope this cleans it up. Oh, that's compiling a little faster. Okay. No, it doesn't like that. I guess we gotta give them lines. Print line. See what that one does. Well, maybe I'll have to look at how to clean up our serial prints a little bit. No, I mean, I purposely took out the new line. I thought that I could wall them off, but I guess a wall and a new line might do it. I've done this in other serial prints in order to get it to plot, but serial plotter. What is that doing? I've got, it's not showing, but it is all there. It looks like, I don't know. I've got multiple things counting. I think I've thoroughly confused my serial plotter. Like, I can see the values on it. They are fluttering between values. Blue is right there. Why is that one 35, 36, 37? One of them just keeps going up. Oh, I see what you mean. Yeah. That's a better idea. That's what I forgot. Yeah, what you guys are trying to tell me. There, all the values, and then next line, all the values. That actually might make it stable on the scrolling view too. Good point, good point, good point. Bar is a different graph meaning to /r. Huh. Let's see what we get on the other end of this. I did say stuff, right? Yeah, stuff print line. So that's actually easier for us to read and see the values move. Although, is this 7, 6, 5, 4, 3, 2, 1? Okay, so it is, that is all of the values. So actually this is the way to make it much more stable, huh? Even though if I do adjust one, it makes all the lines completely discombobulated. So 7 is apparently E1, which I don't think is the order. Oh, I see. Okay, so it is discombobulated. 4, 6, 2, 3, 1, fade, 5. So crossfader, we're not getting. E2, we're not getting. E1, E3, E2 is in the middle though. And the values are pretty stable. These are nice stable values. They're not moving all over the place. My 0, 1, and 2 might be mixed up as well. Because, yeah, the 5 and 3 are not moving. So we may not be properly triggering the mux. A, B, and C pins, 54, 6, and 5. Let's reverse the order, I guess. Try that. Yeah, the excruciating part about this is the upload time. But as the program balloons and gets more complicated, it'll make more sense. Everybody's wrong. Why are 2 of the values moving at the same time? 7 and 6 are moving. They're all moving. Except for those at the end. What? What the heck? Dwell time, maybe? Are we not? But even if I just hold it there, we get the same for 3 of them. Weird. And yet, okay, that one's moving all of those. This one's moving all of these. Now they're all maxed out. Okay, so dwell time between pins. If we give it a little bit more time, so once we've gotten our values and we put them in the serial buffer, we basically wait. Delay. I have to use a delay here. I hate that. Delay of 20 milliseconds is an eternity for a microcontroller. So this will have to be relegated to a timer. But let's see what happens if we give it a big delay, and we'll lineage it back until we get a nice small delay in there. And that'll let us know what our timing parameters are for the code above. Now, I don't know if my A, B, and C are in order. Although we got multiple, we can't know until I slow it down enough that our knob reads are going to be slow. So let's try that. And this is just how we're going to be coding this kind of stuff. It's just these little things. No, it's not shorted pins. All the pins on this thing work. This is basically an unaltered product. And I know that the product before this worked. Oh my God. Listen, guys, you may think that you're smart, but you're not as smart as day-old Wendy's chicken strips that were microwaved, put into a tortilla, and eaten right before talking exuberantly for 5 hours, smart. Okay? That's why in the middle of what I'm talking to you guys go, just like explode. Because my stomach it hates me. It hates me. Okay, so I think we're still co-reading, everybody. It is a whole lot slower. So our dual reading of pins is not, it could be a bad pinout going into the mux. But interestingly enough, we are getting an analog read on all of these, but it's varying from one to the other. So I think that tells me that my mux pins are out of order. So we'll go back to A, B, and C. Is the bit read what's going on then? Maybe the bit read is in the wrong order. There's a biological war going on in your stomach, yeah. Maybe like that. Wait, but that's just the equivalent of what I just did. That's the same thing as that. That is, so we do have a delay. I put a 20 millisecond delay in there. Let's go back to A, B, and C and just see if we're still not reading. It could be the A, B, and C pins, and it could be that I have a wrong pin. But we are definitely reading from the mux. Because 54, 6, and 5 are supposedly the pins. See if I got them right up here. PD2, PD1, PD0, yeah. And then mux 0 is PC0. And we are getting a variable read on the mux output pin. So that part of the pinout's right. Specifically. The initialization being below the actual usage is a little weird. So that one actually does something. But it does all of those at once. What? Why are you like this? I mean, it seems to me like it's not moving the pins properly. Oh, you think it's reading too quickly. So instead of the delay being there, we set the pins. We'll have wait. Try that. Yeah, I think you're right. I think you're right. The weird part is, though, when it cycles, it's going and getting the same value for multiple knobs, and I know the knobs are in completely different spots. Can I ask you to avoid one mux and read just one pin? Yeah, that's probably a good idea. We should probably do that. It's going to take forever because it's uploading 75 times. I was just very confident in my ability, but it seems like we're going to have to manually toggle pins to see what the heck is going on here. So what I can do is make a new void, and instead of do mux, we're going to do mux test. Which also, this whole thing will go into chaos if I press a button. Oh my god, a pad's been touched. Kind of neat. And that way we're not effing with this 20 millisecond delay. Instead, we're going to do void mux test. And mux test is going to take a digital write of mux A 0, digital write mux B 0. Although that's going to take forever. I'm wondering if I need to set it up in some other way so that it does iterate through it. It just does it very slowly. Or like manually do multiple. Just make it a huge annoying program. Because like this is as simple as it gets for iterating through, but somehow I'm not seeing my bit reads as working out. I don't know. So we're just going to pull it back even further, and I'm just going to do an analog read here. Of mux 0. Stuff print. I'm going to get a permanent wrist injury from the angle of this keyboard. Stuff print. Just like that. And that'll go through quickly, but it'll only be reading one thing. And so we can see if it stabilizes, and we can see what the knob value is supposed to be, and I can add on to this. Well, we'll start at 0, 0, 0. Let's start at the 0th one. This is gonna take time, but we can do this just because we have everything set up nicely. So the more stable your setup is, and the more you can iterate code like this, the happier you will be with the results, and you can get to the bottom of some of these weirdnesses. Oh, mux 0, mux out, mux O. Muxo was his name-o. Bingo was the name of the dog, right? Not the farmer. I don't know why it's this farmer has a dog, but the farmer's name is Bingo. I don't think that's the song. I don't think that's what the song's trying to portray. B-I-N-G. Oh no. So 001, 400. It moved a little bit there. It really shouldn't have. Oh, because my thumb. No, I didn't. Okay. So 001 is E3. And they go from 14 to 1,000. I wonder, maybe we should mark them here. But that's 001. Where's that data sheet? Hold on, 001. And we can see which ones are A and B and C. Because right now we have E3, right? Yeah, E3. E3 should be connected to pin 1. Pin 1, 001, channel 1 is that pin 1? It doesn't have a pin number on it. Why would you do this to me? Which one are we? Hold on one sec. Channels in out, common. Channel 1 is on pin 14. 14. Channel 4 is on pin 1. If that would mean that A and C are reversed. 14 goes to E4. That's on channel 1. E3 is on pin 1, which is IO4. 4 is 100. So it is the opposite of the way that I have it. So in what I can do, and we need to verify that this works by looking at the analog output. We're doing multiple things every time we do this, right? No, we're 001. No. This is the fascinating thing here is we've got my pinout, we have the CD4051's behavior, and then we have the A, B, and C lines, right? So the A, B, and C lines, supposedly, if they're hooked up correctly, I've given it 001, right? I've given it 001, which is not coming out as channel 1, which would be E4. It's coming out as E3, which is channel 4, which means it's a 100. So if I reverse those two pins, my A and my C pin, we should then get E4. So let's reverse the A and the C pin up here in my pin matrix. So PD2, PD0, PD012. Interesting. Upload. Now let's see if knob E4 is what's shown on the thing. This is verifying multiple different stages of things happening. That we've got good pins on the mux, that we're reading from the correct pin, that we are sending it the correct designation for the pin. All these things are tested all in one. It's kind of cool. Yeah, you're right. I did set it to 000. Wait a second. That doesn't jive. And I left it printing 001. Okay, well, we're going to get the exact same result then. Yeah, it's still on E3. So, okay, never mind. All the fun stuff that I just said is not true. We should be sending it 001. Let's try that again. Well, why did... Okay, so hold on. So I got to mark that down. That E3 was 000. 0, 0, 0. E3. It could be a pinout issue then. If we were seeing channel 1. Because that don't make sense. But it could be that one of these isn't being properly initialized. It could be if it's on a different pin, that's trouble for us. And this thing is so densely populated that without getting the oscilloscope in, it's going to be hard for us to see. Like everything here has a job. Everything. And our mux pins are all over the place. Like A and B encoder. The knobs. This would be the settings, I think. And there's another one somewhere around here. See, there's a lot. Okay, so let's just try the next number in the sequence. So my A, B, and C thing might be off because it seems like it's a little crazy. Let's see what result we get for 001 then. What's up, Copper? Whoa. Oh, it's the same one. That's still E3. What? Why is that still E3? 000 and 001. So that means that we probably have a wrong pin for the mux, I'm thinking. One of them is either held high or low, or is it inverted? I don't see why it would be inverted. But it's still only reading from one of the pins, so. All right, so we got to double check our mux pins. I hope I don't need to take this thing apart to verify the pinout, but that may be the direction that we're headed in. So if I do 111, yeah, we do have pin mode for the mux pins that I've got going on down here. Out, 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 and then mux out as input on the micro. I'm wondering if our mux pins are not our mux pins. Because we set it to all 0 and it was still the third one. So just send it 010 and see what happens. Oops, I didn't do this. Ah! All right, well, it's going to say 001, but it'll... We'll know what it's doing. We'll know in our heart of hearts. I may need to trace the mux again and figure out where those inputs are going. What pins it is. And whether they're held up or down. So this is 010. And it's still E3. Set it all ones and see what happens. Because then we'll have to pull it apart next if we send it all ones and it's still E2 or E3. It could be that the logic is inverted. In which case, I don't know what I'd do. Now it's E1. It's no longer E3, it is reading from E1. With a 111, it is reading from E1. E1 is on pin 5. 5 is 101. Could that middle pin, or the high pin, could that be misreading? The mux B could be misset. It could be some other pin. So we have to actually investigate, because if that's being held at 0, then this is 5. Or it's being held, yeah, held at 0, and the other two are going 1. When the other one's set to 0, it would be like 1, 1, which is 3. But we're not seeing 3, we're seeing E3, not E2. But something funky is going on with the binary. So I think we need to just look at the pinout again. I need to physically open the device up and look inside of it. I didn't want to do that. I thought my pinout was infallible. So disconnect serial. Disconnect SWDIO. My serial pins are also kind of fragile, so I have to be careful around them. There, let's go from here. Go from here. I put all the screws back in. Ah. Yeah. Ain't no torque spec on these things. But they are actually screwed in such a way as to not harm the plastic, because we're opening this thing up way too often. And if you're not careful, you can strip these posts pretty easily. They're not machined, they're not molded with threads in them. The screws that they use for these plastic things are much akin to wood screws, and they damage the plastic a little bit every time they go in. So when you re-screw these, you go backwards at first. And you can feel when the screw clicks in to its previously machined thread of the plastic. And if you do that, they'll last much, much longer. These are, I think they're zinc coated. Okay, so now we get to take a look at the mux, A, B, and C. All right, where's pin 1 on you? So pin 1's over there. So we got the pin that we're looking for, 11, 10, and 9. So pin 1, 2, 3, 4, 5, 6, 7, 8. And because we previously would number these on vacuum tubes going anti-clockwise from a gap, what number did I get again? Was that 8? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And those are our A, B, and C. So C we can see. A, B loops over A. That one goes there, which is a weird spot. And then we've got all 64 pins of this mamma jamma over here. So our A encoder, or sorry, pin 9, C, our most significant bit. Is it our most significant or our least significant? Hold on, most or least? MSB and LSB are important in binary. If you haven't learned about binary numbers, the ones and the zeros have different values to them, and so your least significant bit is the one that changes more often to have less of a value change. C would be our most significant bit because halfway through counting it turns into a 1 and then it stays there, and it has the most profound effect on the number that you're sending. So MSB to LSB, our LSB is 8, so we are going and tracing our MSB, which is the pin for pin for C, which is down here at the edge of the chip. So C is looping around, and it is going to R75, and then it goes, and then it goes up to that pin. Here's pin 1, and again, vacuum tubes, 1, 2, 3, 4. Pin 4 is C. Pin 5. Dun, dun, dun. Double check. Oh, maybe I didn't see that. So 1, 2, 3. Okay. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5. Pin 5. Oh God, this is impossible. Hold on, wait a sec. I have a way to do this. I got this. I got this. Where's my mouse? I have too many monitors. One, two, let's hold on, wait. This one is C, going up here to U. 1, 2, 3, 4. Yeah, it is pin 5. Pin 5. And pin 6 should be B, because B loops under the chip, and it goes to this one, which puts us to pin 6. And then pin 54, 64, 63, 62, 61, 60, 59, 58, 57, 56, 55, 54. It's this one. So that one there, the first one in that little split off, supposedly, and I can see it right now, it goes up this way, up that way, under to here, and it goes there. And I can double check that with the multimeter. Ow, 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 these things hurt. I got really pointies on this thing. Trying something I have never done, printing with TPU. I got a roll of TPU, I haven't printed with it yet. I wanna try. I don't know what to print. I made a project box and want a rubber anti-skid mat on the bottom. Prusa Mark IV doesn't have settings for TPU by default. Yeah, I gotta look up what the settings should be. It should be on the TPU itself, right? They should tell you. So we're going from here. These are nice and easy to probe. Just nestle right there. And then we're looking for a 330 ohm resistor. Or a 33 ohm. Yep, and we get a 33 ohm resistor on the multimeter. You guys can't see the multimeter. It's over here. Bed properly licked. Lick the bed for good luck. Weird. Weird. So right there, 33 ohm. So I am infallible and my pinout is perfect. So we need to make sure that we're setting this thing correctly. When I power this thing up, what do I have it set for? Try the shit out of that shit. I don't recall asking for YouTube's advice. No. I have some glue stuff, but I think the PE bed I have, so it's pretty good. I see, I see. Yeah, what are you supposed to do with TPU? Do you put down glue stick or do you put down something else? If I power this up right now with the code that we have in there, we should see 111 on all of the muxes. That doesn't really tell us much because I think these pins default to 111, but I guess I can go off of the ground pin. What are our ground pins? Pin 8. Okay, so I can get ground there. I can go to voltage on the multimeter. We don't need the oscilloscope for this. So if I power this thing up using SWDIO, Swoodio. arise. And then I go from this pin, which is ground. Here, I need the microscope to see what I'm doing. Micro spring arm. What's going on? Oh, wait. I had my hand down on the thing. What? My arm was leaning on it, and I think it made the power all weird. Wait, so that one's 3 volts. This one is... Ooh. Not 3 volts. Middle pin. Not 3 volts. What? Yeah, why are we getting weird results? Two volts. 2 volts. What? Have I not put in the correct pin values? Okay, let's double check our pin values then. It seems like maybe a pinout issue. There, I'll disconnect power to be nice. Okay, so pin 54, 6, and 5. Double check the values per P, PB, and P whatever. PD2 for 54. 6 and 5 are PD0 and PD1. And I have them in PD0, 1, and 2. Zero, 1, and 2. We are defining them when we init mux. We init mux down here. And init mux is all the way down here. And we pin mode A, B, and C are outputs. I mean, I could set them to 0 on boot, but I don't think I need to do that. So I don't know what's going on here. The pinout is not doing its thing. Even though we have the microcontroller setting those pins to a value, it is not doing what we need it to do. Digital write mux A, 1. Digital write mux B, 1. Mux C, 1. I mean, I could put in high, but it's the same thing. Or I could put in true, it'll do the same exact thing in Arduino. So it's a little strange that setting all these to 1 and I'm getting 2 of them set to 0. Why would it do that? I don't know why I would do that unless there's something wrong with the core. I've double checked my numbers about 5 times now. Oh, well, let me double check that my arm didn't like short out the program and make everything fail. I'll just plug her back in. And then redo the voltage test. We need the microscope for this because otherwise I'll be pointing all over the place. So ground over here. Just stab anywhere, it's fine. Oh, I need multiple windows or I can't see anything happening. All right, ground over here. Huh. That one's high. What the heck? These are coming directly out of this thing. That one is okay. But these two down here are not. They're all the way down here. These two on the end over here. What the butt? I mean, we're using the right core, so it should be able to access these PD banks. And we're doing like a digital write. It's as simple as it gets. Pins 5 and 6. Which, from what I understand, I don't think there's anything special about pins 5 and 6. They have C in and C out are alternative uses on that, but I don't think that's in use when the programmer is connected. We're next to N reset, but if I set them to 0, pins B and C, right? Set them to 0, maybe they'll show up as 1s. PD1 and PD2. Let's find out. Let's see what happens if I set them to 0. And we're connected with SWDIO. We should be okay. Let's see if I may have to unplug and plug back in USB or something on it. Very strange behavior from the microcontroller. Problem is you could probably count on one hand the number of people that have used this specific ST micro core. So if there's something wrong in the core, I'd be the only person to learn about it in like 10 years. ST-Link error. Okay, I left it plugged in. I need to unplug and plug back in. Board at COM8 is not available. Yeah, I'm aware. Sometimes this gets into kind of a weird state because the COM port and the USB programmer. Okay, so now we need to take a look at it again, and I need to test those 2 pins and see if they are at 1s. No, they're still at nothing. They're still at a weird kind of floaty state. And this one, did I make everybody 0? No, Mux A should still be at a 1 level. But now this is at a, so C is on, okay, so that one's C, but that's actually, so my A and my C need to be reversed. At least we got that. But that one should be at a 1. That one should not be at a 0. What the heck's going on with this thing? Is there something else that I need to be toggling? Do I need to be turning on the chip? I don't think so. So my A and my C were correct previously. This is PD2. This one's PD0. I'm going to hit Control S on that. It's just that B and C are not doing anything, which is odd because this thing was working before. I don't think it works in any kind of a special way because, I mean, we can trace it out. It just goes right over to these 2 pins over here. So is it possible that those pins are being used for something else? We need the ST micro data sheet so that I can take a look at what those pins are and whether or not I need to be doing something on some other level that'll enable those pins. I have it open. No, I don't. There it is. PD 0, 1, and 2. I mean, they're IO. CAN, TX, and RX. I don't think that's the right, oh, remap. Main function after set. And then remap CAN, RX, and TX. We haven't done anything with CANbus on this within the ST micro stuff. So, wait, PD, no, that's not right. Oh, it is. PD 1 and 0. I thought CANbus was on different pins for this thing. Maybe I'll look at the wrong part of the data sheet. Because, yeah, CAN transmit and receive was on PA 11 and 12. Or 12 and 11, rather. They happen to also be the USB pins, which is really helpful. Wait, is chat off? Why is chat off? No, that's my glucose level. Where's chat? Frame chat is there. Why is it invisible? One sec. We're going to jump into frame chat. I must have hit the button by accident. Oh, yeah, the the magnet on the back of the multimeter hit the turn off chat button. The shut up chat button. So I can just hit chat hide and they're back. Okay, there, you guys are back now. Okay, sorry about that. That's the big ass magnet on the back of the multimeter. I don't understand. So CANbus is here, but it's also C in and C out, which happen to be two of the pins that I can't have any influence over. I need to turn those into PDs instead of C in and C out. It's strange to me that over here we have CAN transmit and receive on different pins. I guess that's a different function on the same chip. It's very, very strange for me. I'm trying to adjust. So yeah, USART 3. How do I get them back? USART timer. Default to that. Yeah, see here, CAN RX and CAN TX on those pins. For some reason, these are CAN RX and CAN TX over here. And the only reason that I think that it's not writing, the Arduino is unable to write to those, is that it's assigned to be some kind of a UART pin. Some kind of a UART pin that's being assigned as a UART pin and not as a general purpose I/O. I don't know how to do that within the core, the ST Micro core. CAN library for Arduino STM32. Well, that'll be something that I can look at later. Universal CAN library for STM32 Arduino use. Originally, this was created to be used with Speeduino CANbus project. That actually might not be useful for us, to be honest, because I'm only using CAN in one place, and I need to be using a TXRX CAN. But I'm just looking to see how two Arduino boards communicating with each other in CANbus. Arduino is connected to via MCP 2515. All right, so it's using a helper. Yeah, they're talking about using CANbus like directly into the chip. We're going to be using like a little boards that'll help us do that. That way we don't blow up our blow up our stuff. All right, so hardware aside, oh, you're just using the SPI. Cheater. That's not using the CAN specific pins. Yeah, this isn't helpful. Because they're going to be initializing SPI and not general purpose IO. Yeah, because this is very frustrating, because I go to write these pins and these pins aren't writing, and all I can really think is that they're trying to do something UART-y. We're not using the UART, we're using the software serial in order to print all of our stuff. And when I initialize the pins, in our initialization, I am setting them to be outputs. Here. Output, output, output. These pins ain't loyal. 5 and 6 in the LQFP48. We have yeah, there it is. The 64s in that list are configured as OSC in, OSC out after reset. However, the functionality of PD0 and PD1 can be remapped by software on these pins. OSC in and OSC out. We are using SWDIO. It's possible that if I unplug the SWDIO, these pins will start working again. But then, well, if I unplug SWDIO, we can still get a serial read off of it. So if I, well, oh, but I can't, no, we don't have power coming in from the serial. I don't have power coming in from the serial reader. I could pull out the anything but the power pins on the SWDIO, and then it would power the board. Yeah, I'm just a little bit like, I don't know where to go with this. I don't think the SWDIO programmer is toggling them into these functions. We have in our software, we're declaring them the way we should. I don't know. Unless PA, well, but our C pin seems to work just fine, right? Like that one works for PD0. I wonder if PD1 and PD2 are like ill-defined in the pins for the STM32 library. I don't think that's the case. Maybe there's probably not something in the examples. I would like to take a look at some of the ST micro examples. Looking up Blue Pill itself, the Blue Pill board doesn't have the 64-pin version of this thing. So what I'm looking for is, yeah, see the Blue Pill pinout is a little different. I wonder if they have PD0 and 1 and 2. That doesn't even matter here. So we don't need that right now. That's something we're going back to. So STM32 Arduino library. 32 Arduino on GitHub. Is this? Yeah, I think this is the one we used. Ethernet, low power, RTC, SD card, forum and discussions, examples. Several function packs, commodity uses X Nucleo boards. That's not what we have. Nucleo car, a funny example. Ha 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 ha. Ha 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 ha. So funny. Ha 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 ha. Okay. Oh boy, there's a lot going on here. Man. How about looking up PD1 and PD2 Arduino STM32. Is this really gonna... GPIO pins belonging to port D, which can be accessed and controlled within the Arduino IDE. Using the Arduino core and many common STM boards, PD0 and 1 are often used for the external crystal oscillator. Dun, dun, dun. Something here is not allowing us to have those pins be GPIOs. So how do we get them back? Is this really gonna... Can be remapped as GPIOs if an internal oscillator was used while PT is generally free for use. What are they going to tell me to do? Pin mode, output, input pull-up. Okay, so doesn't work. Dang it. Because we're doing that. We're doing this. This is so... STM32 F103, PD0 and 1 are connected to OSC in and OSC out. Is that, because that was C in, so maybe that's what that meant for C in and C out. No, see, OSC in and out are on P9 and P7, which we are using successfully. We're using those just fine. So those aren't necessarily, it's C in and C out, PD0 and PD1. Although, if this is doing something to those pins, clock in it, peripheral in it, peripheral clock init type def. Well, structure, RCC, HSE. I'm looking for something that looks like what we're looking for. These are all the clock calculating things. Clock init structure, clock type, divider 1, divider 2, RCCH clock, peripheral clock init, RCC, ADC, div 6, div 5. Hell, okay. I wonder if there's something that we need in here that'll re-enable those two pins. Oh boy, but I'm not smart enough for this. Because according to, again, AI doesn't know what the fuck it's talking about. So according to AI, we just have to define it as an input within the Arduino parlance. But I have a feeling that calling on this stuff in order to make the system clock internal has some kind of a thing that it did with those two pins of the bank. Even though technically the oscillator pins are not pins 5 and 6, they are pins 3 and 4. And those are already connected to LED P9 and P7, which I know work because I've been working with the LEDs. So I don't know if something we did killed two completely, these are different, but then again, I'm seeing weird behavior on them, so I don't know. And there's not much else that I can test. That doesn't make any sense. No, that doesn't make any sense. So why are those two pins not working? PD1 often pin 49 to 50 on the 64, often pin 50 on the 64 LQPF. Yep. Better to refer directly rather than pin numbers. I mean, it's not wrong. AI would probably, what is this probably? No, no, no. This is a different core, so that's not really gonna... Oh, STM32 wiring to pins PD1 affects PD0. That's not us, that's not our problem. It is kind of grasping at straws at this point. Found the macro eventually usable to remap these pins. AFIO remap enable. Whoa, what is this? So let me see here. So you've got, I just want to understand. 103C8, so that's very familiar. Pins PDOs, PD1 not working. So that's configured all the blah, 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 blah. Okay, PD 0 and 1 are used for the external oscillator by default. Not in our chip. I don't know if maybe they just weren't working with the 64 pin one. It's possible that they made the core for all their others and they just kind of whiffed on the 64 pin one, because our pins are if we had an internal oscillator, they would not be on C in and C out. They would be in OSC in and OSC out. I wonder what C in and C out are doing, but in that vein, directly affecting them, as this person had trouble with PD 0 and 1. GPIO pins, so oscillator by default using OSC in, OSC out pins as GPIO ports, PD0, PD1 in the reference manual. 32 cube, blah, 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 using OSC in, OSC out, HSC oscillator, blah, 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 AFIO mapper, map R. The remap is available only on 36, 48, and 64 pin packages. PDO and PD1 are available on 100 and on 144 pin packages, no need for remapping. The external interrupt function is not remapped. PD 0 and 1 cannot be used for external interrupts. Okay. 48-pin package, you need to set your AFIO mapper PD1 remap to be able to use the oscillator pins as PD0, PD1. It appears that Cube and HAL you can use AFIO remap enable. I don't use Cube. Note, to be able to do that, the AFIO clock on RCC has to be enabled first by setting RCC. These are weird commands. GPIO init struct. What are you? Static void MX. So everybody's talking about like different boards. So yeah, so you've got, what is this? Remap PD0, PD1 from OSC to normal. GPIO, AFIO mapper. AFIO mapper PDO1 remap. Woo! So we only have to do PD1 and then they both should work? Because it's funny, we're having trouble with these pins in that we're not able to do anything on these pins. We have remapped the generic oscillator to be internal. That should affect pins 3 and 4, not 5 and 6. That should be affecting oscillator in and out. But we see reference to pins 5 and 6, PD0 and PD1, being the oscillator input pins. So it's possible inside this core, it's not doing the right thing. So, oh my God. Okay, so we do all this stuff, and then I guess down here, I don't know if it's peripheral init, or if we use AFIO remap, or we do, I don't even know, man. AFIO remap enable. See, all these are RCC stuff. And then this is peripheral clock init. ADC, USB, HAL RCC, clock config, and peripheral init, not HAL OK. But if I just have this, is that going to actually do something? Maybe? From OSC to normal, GPIO, AFIO, mapper, wall equals, AFIO, PD1 remap. So it's the same command. Okay, let's try this. Let's see if that fixes it. In which case, we are looking for ones on all of the positions. So 1, 1, 1. And then we're plugged in, we're initialized. Okay, so I'm gonna hit upload on that. Maybe that command will do it. I don't know. Seems like something in the Arduino core isn't quite catered to having an internal oscillator run everything, but because they wanted to get, they were pin maxing for the 64 pins that are available, so we don't have a clock. So we had to do all of this weird dark magic in order to get it running without a clock. And I think I may be the only person to do this in Arduino. So let us see what we got. I guess we need multi views so that I know what I'm poking. And then U to voltage. That's utterly fascinating and completely annoying. Oh, and it didn't yell at us for the functions. So this one right here. Still 0. Still 0. Still can't use them. So whatever I put in there did not work. What a struggle. What an annoying struggle. I know the pins that are actually associated with the clock on the 64-pin pinout do work as GPIO. But citing specific examples of people having trouble with PD0 and 1, they put this code into it, which AFIO remap enable, AFIO mapper PD1 remap, should get this working. This, however, I don't know if that's ever called. I don't know when this is called. It's called somewhere in order to enable those pins. Maybe if I just put it up here in my initializing, when we initialize the mux, maybe? That's silly though. It should go with the other one when it does all that other mapping, but let's just try it here. and just see what happens. And see what happens. And see, there it goes. This is very confusing. This is getting into that deeper microcontroller stuff that you don't deal with Arduino. You don't deal with it. You don't have to. But initialization stuff is important with microcontrollers, especially if you're using one straight out of the box. Or if you're trying to get weird stuff to function, or if you're pin maxing, which is what these freaking people did, and it causes nothing but grief. That one's high. What about you? That one's high. It worked. That worked. You guys did it. Holy shit. Chat. I could kiss you if I wasn't completely revulsed by your... Oh god, it's almost 3 o'clock. I gotta go feed the dog. One sec, guys. Oh, let's just put up a thing. You guys did it. That's really cool. So now we can actually discover what these things do. But the secret was I have to run AFIO remap enable AFIO map PD01 remap PD0 and PD1 and PD2 reassign to GPIO. Just like that. Man, that was smooth, you guys. All right, so I'm gonna go to face cam for just a second. Literally just need to heat up some chicken so that it's not cold. And then get that into her food and then give her her food bowls. And then we'll be good for the afternoon. I'm gonna come right back. So I'm gonna put up, do I have a BRB in here? I thought I had one. Yeah, BRB. And then I'm gonna put up some, I just had 2 hot dog sized cheesesteaks. I used to go to, not anymore. I used to go to like high society party stuff. I had a lot of really well-to-do friends. And so they would get this catering service for their hoity-toity lawyer party. And at the hoity-toity lawyer party, they had little mini cheesesteaks. They were awesome. This is little miniature cheesesteaks. Ooh, I want a cheesesteak. Nom nom. It was just a little bite. I actually made cheesesteaks the other day. We got Amoroso rolls and we found the like shaved meat. It was awesome being able to make it yourself. Some little brat rolls from Walmart. That sounds, yeah, exactly. That sounds really good. Okay, so let me find my text in here. Trigger warning, needles, blood. Well, that's not feeding my dog, you monster. Jeez. Is that okay? Okay, I'll be right back. The secret to like a real cheesesteak, don't let the food YouTubers fool you, because I saw Future Canoe try to make a cheesesteak and it was horrifying. You can bake your own bread, that's fine. It's just you need to be using the steam kind of cooking to make it. You need a papery crust. Like it's like biting into paper, and then you need a very soft bread. Amoroso is the one that makes the roll. Everybody can fry steak, right? It's that roll that's really going to make or break your cheesesteak. I'm going to be right back. I'm going to put on music for Twitch. It'll only take me a second. I just want to get my dog food. Be right back. No show. She's probably sad that everybody's gone. I'm the only person home right now, but I'll hang out with her in a couple hours and then she'll probably eat. Doink. Okay, I'm back. So we got PD0 and 1 to work, so now we can actually investigate those 2 pins. Pretty cool. Bonk, and then BRB is where I need to make that button look a little brighter. Okay, what are you guys talking about? You got to wrap it, that makes the sandwich. That's true. We didn't wrap ours when I did the homemade cheesesteaks. That would have been a good one. There's some guys with a 70s fire chef mustache. What? Oh, fire chief mustache. Fire chef, fire chief. How can't I read words? I can't read. I never learned how to read. Most cold meat sandwiches taste better when wrapped tightly or vacuum packed if you're fancy and tossed in the fridge overnight. Yeah, a lot of them can benefit from that, I guess. Hooked on Phonics worked for me. See, I can't even pronounce. I can't even say it properly. I can't even say hooked on Phonics worked for me. Okay, we got them working. That's so cool. Okay, so now I can go back to what we were doing before, and I can put this thing back together. It's, you know, my pinout is infallible. I am infallible. We've verified that. I won't put the screws back in. I'll just leave it like this. I keep forgetting, not in love anymore. Oh, my falsetto is not as good as it used to be. Every time I just gotta sing it like octaves lower. I keep forgetting, not in love anymore. Things will never be the same again. I keep forgetting. Every time I move, really pull a while. Okay, shut up. Shut the fuck, just shut up. Okay. All right, we are all plugged in there. I can plug into serial now. And we know that our 1s and 0s are all the right 1s and 0s. So we can now start with 0, 0. Actually, it's the other way around. It's CBA. So that's 1, 0, 0. So if we're going 0, 0, 1, it's 0, 0, and then 1. A is the least significant bit. And let's upload that once it's done saving. Boink, upload. They took away phonics for new readers. Apparently they teach you to memorize the shape of the word now. It sounds like, that sounds kind of like a shortcut where you're not actually learning properly stuff, but I would assume that those people are smarter than I am, so. So reader, 001. No, whoop, moved a little bit. There it is. So now we are reading E6. On 001, E6, and we've got to reference our references here. Double, triple reference, the reference of the reference. Deference of the reference. Let's get rid of some of the noise. So we are on E4. We are on 001. 001 goes to channel 1. Channel 1. Where's MS Paint? Did it freeze? There we go. No, my computer was being weird. 001, channel 4, E3. Well, we're reading E6, channel 2. How would that be channel? That would be if it was 010 for E6. 010, we're sending it 001. Is somebody inverted? Yeah, see, that's this one here. These are stable knobs, though. These are pretty good. From 14 to 1,000. We're going to scale them back a little bit because I don't need I can send much smaller packets if we just go 0 to 255. And like 915 versus 926 is like indistinguishable. I don't need as much resolution on these. And if I do, I guess I can bake it in later. But okay, so we're reading from E6. And I'm sending it, well, wait, this is saying 001. Is that what I set it to? No. 001. So let's send it 010. Oh, I need to, no. I keep forgetting to change the serial print. Literacy rates and scores nosedived when they put in the new system. Why are they? I don't know. I'm not going to question. No position due. Okay, so this is 010. And it's still, no, this is E4. So, okay, 001 was E6. Here, let's take a picture of this. What is she? Oh my goodness. My dog, you can hear her barking at stuff. And she's just going, ooh, woo, 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 woo. It's almost a howl. I'm going to jolt these down and it'll be more apparent what's going on. Define serial stuff, ugly hack. What do you mean? That's going to be way too big for my drawing. What is it? Alt? Nope. Shift, Control. Shift, Control. Shift, Alt. MS Paint would never be so kind as to give you the ability to scale things down logically or squarely. I'll just put that there. So, okay, so what we're getting currently with all three of the pins working, supposedly, is right now we're doing 010, but 001 is E6. 010 is E5. Is that right? No, E4. And E4 should be 1. E6, where are we? Oh, should be 2. These are swapped. So my B and C pin are swapped? Wait a minute, that doesn't make any sense. Why would B and C be swapped? Oh, because B goes around A. No, but then they wouldn't swap. No, these two swap positions. Because on the chip, it's like this, and one goes like this, and the other one comes out here. And then they go over to that bank. So yeah, those two are swapped. So now, it's starting to make sense. Everything's starting to kind of fall in line here. So it's actually 0 and 1. The RGB order is all ganked. Upload. Yeah, we're doing this in sort of the very basic way that you would do Arduino programming, as from a very rudimentary standpoint. And I like that because this is very direct. A lot of the stuff we're doing is very direct. We've had to do some weird microcontroller tricks. Like when you read on this stuff, I start hearing like a low humming noise, and then there's like evil Gregorian style chants in the background. Flames start to flicker up from below as Satan himself is being summoned by your incantations. I don't know what this stuff is doing. It's evil, dark magic. We looked around for why PD0 and 1 wouldn't work, and chat said that I need to initialize them using a little piece of code that other people have used in order to get PD0 and 1, or PD 1 and 2 working, because on other chips, on other pinouts, they're used as clock pins. So I think there's probably something deep in the sort of the subcockles of the core that wasn't reconfigured for the 64 pin, and so it disabled those 2 PD pins. But since we're using almost every single one of these pins, we had to do a little bit of dark magic here in order to re-enable. Hey, what's up, Big John? How you doing? That's right, you got that 215 one this time. They were talking about cheesesteaks earlier. I had to set things straight. So now that we've got those pins functioning, supposedly, after swapping those two, we are going to be reading 010, which is going to be 2, because 000, 001, 000 is not plugged in. Bank 2, so that should be E6. So let's see what we've got here. E6, COM8, and then E6 is this one, I think. It's this one. It's not that one. Shit! Which one is it now? It's E3. What the butt? 3 is 011. No, wait. 012. Yeah, 3 is 0 1 0 no. Wait. Yeah. 0 1 2 3. Oh, but E3 is on pin 4. So accidentally 100. Okay, so hold on a minute. I'm gonna figure this out. I'm gonna get this. This is like remapping RGB. If we're supposed to be 010, but we're accidentally 100, so are they all backwards? PA PD201 102. Wait a minute, that's not right. What is it? Hold on a minute. Shit. If I make it 7110, we either get 2, 3, 7 or okay. Check to see what happens with. I hear motors outside. I think they're collecting trash. I think that's what's going on. B and C were reversed. We had those in the wrong place. PD2 and PD. Oh, because okay, hold on. Control Z that. Would it be 120? I don't know. I'm bad at this kind of puzzle. Let's see which one it's supposed to be. Let's see which one we got here. I got 3 pins, and I'm guessing which one is which in order to get the A, B, and C. So I guess I should probably look at this from the other direction and try to get an expected outcome from the mux. Luckily for us, all these numbers have been very stable. There's not a lot of like jittering between numbers. So I think the capacitor thing, putting a capacitor on the line from the potentiometer is probably a really good idea. I should do that more. Okay, so in the configuration that we have it now, if A, B, and C are in the proper positions, we should have a 0, a 1, and a 0, and that should give us channel 0, channel 2. Channel 2, which is E6. So supposedly I go to the serial print and I go to E6, which is this knob right here, and that number changes. Okay, we are at E6. Now, are A and C flipped? We will not know until we change the value of one of them. So changing the value of A gets us 110, which should be channel 6, which is the 7th channel. So if I go 110 by flipping channel C and I hit upload, this one should be channel the crossfader. This one should be the crossfader. It's a lot of this type of work is referencing references of references. So we've got a pinout, we have a pin number, we have a pin ID, we have a connection to a mux, we have a pin address, we have the potentiometer control. Everything is referencing everything. It is not the crossfader. If we got this one wrong, and it is actually, hey, what's up, man? Oh man, IRL, so many, 2 IRL people contacting me in a row. My buddy John from Philly and my cousin from Australia. I said that perfectly, didn't I? I said that with exactly the accent. Yeah, I know I did. He's from Australia. Yeah, I don't fucking know. We're referencing things that are referencing things that are referencing things that lead to the controls of this drum pad. Because this drum pad happened to have the same microcontroller that it had a microcontroller that we can actually reprogram. And so I'm sort of clawing myself back to being able to have all of the same functions on the pad. That means that I'll be able to put it into the CANbus that's going to run the rest of my simulator setup. This is no longer a drum pad. I don't need a drum pad. I've got all kinds of other stuff. So anyway, this drum pad is for controlling things. I've made it so that the button that you hit actually lights up too. All with the power of Arduino and some really weird code. So, okay, so the ones that would be flipped, right? We had a confirmation of the previous number, which was 0, 1, 0. So if those two are flipped, we're either 0, 1, 1 or 1, 1, 0. So if we are 1, 1, 0, that would give us channel 6 on the mux. You can see it down there, channel 6. Channel 6 of the mux goes to the crossfader. That's if we had 1, 1, 0. 0, 1, 1, we're going to channel 3. 0, 1, 1 being channel 3, that goes to E2. So if I go to E2 and I move a knob, it doesn't do anything. Fuck. Something else is wrong. It's on E1. E1 is 5. That's 0, 1, 0. What the fuck? Ugh. Strange things happening in the world of electronics and pin assignments. We've got an ST micro core, and it seems like it's acting up. It seems like something weird is going on. Digital write A, B, and C, 0, 1, 1. Yeah, this is the verifying pinouts and stuff like that. That's part of it. Another part of it is weird stuff going on in the core. I'm probably the second person to use this core ever. So I don't see evidence of 1 and 0, PD 1, 2, and 0. If we count from the beginning and I do 0, 0, 1, which would be A is 0, B is 0, and C is 1. No, C is the most significant digit. A is the least. So 1, 1, 0, counting in binary numbers is never clean. 0, 0, 1. I'm just trying to figure out like what could possibly be configured incorrectly here. Because we verify that the pins are actually assigning when we assign them this way. We were going to iterate through the pins, but things were happening very weirdly, and we discovered that 2 of the pins weren't quite working because we had basically reconfigured the oscillator to be internal instead of external. So with the internal crystal, the 2 pins that were originally intended for the crystal to go into weren't being reassigned as general purpose IO. And so we had to use this cryptic AFIO remap enable to map PD1. For some reason that does both of them. I don't know. But we are declaring them then as outputs. And so technically my code, which is very dumbly using digital writes to directly influence the pins, should be setting things correctly. Let's start from the beginning. I'm going to start from 0, 0, 0 and see what we get on the pins. We'll start from 0, 0, 0. It's not going to do what we think it does. Oh, and my serial print's still going to say 0, 0, 1. That's fine. Waiting. This is like directly controlling the pins. This will hopefully give us an idea of what's going on, depending on which, because every time we try a number, it's telling the mux to try a certain input. So I'll have certain controls work, and we're not seeing any crosstalk from controls too. So that is a good thing. So if we set all zeros, what do we expect? What do we expect from all zeros? We expect channel 0, which is not connected to anything. So I should not have the ability to change the value. Testing, so far so good. Oh, E5. What about, that's not doing anything? So we're looking at E5. E5 is, wait a minute. E5 is 7. So one of our pins is not changing its value. So technically from A, B, and C, CBA, we've got 1, 0, 0. One of our pins is not actually working. Is there something that I need to do in order to remap PD2? Do I need to run that command on both pins? Because for some reason we told it to do that and then it doesn't work. So enable AFIO mapper PD1 remap. So let's put PD2 in there. Maybe that's what we need to do. Try that. That's what was throwing us off, is one of our pins was just locked to a 1. I've never before in my life seen this. Oh, error on COM8. That's fine. You're supposed to be not using COM8, even though it's assigned here, but just for the serial monitor. Did it attempt to? Jeez, what is? Oh, what just happened? Oh, that was my scrolling. Okay. Did you program? I don't think it did. No, it didn't program. What if I close this and then upload? We've got the ST microprogrammer in there, which is what it should use. It's just there's something a little janky about having the other programmer plugged in and programming. It sometimes gets into a weird funk. AF10 mapper remap was not declared in the scope. Did you mean AFIO mapper PD1? Weird. So it accepts it with PD1, not 2. I thought that was going to be the problem. What was the other command that somebody had? The command somebody had was PD1 and PD2 from OSC to normal GPIO. AFIO to mapper. And I guess, I don't know if that's code that I should be putting in, but it looks like that's the same thing that we're doing. And that enabled the one pin to work, but I think we're having problems with the other pin. I don't know what happens to PD2, because it appears to be stuck. Pin C goes to pin 5, and pin 5 is PD0. PD1, oh, maybe we need, not PD2, maybe I need to reset PD0. Why did it do that? It suddenly went to the top of the page. But I think that's going to run into Code Rush rating with a party of both. How you doing? What's going on, Code Rush? We're having some trouble with these things. These pinouts are really kind of getting in the way. What's up, my ages? Running into a little bit of problems with this. PD, that's PC. PD0 and PD1 on other chips, other ST micro chips, don't work because they're meant to be plugged into an oscillator. On our LQPF64, Our oscillator is actually on different pins. It's on PC 14 and 15. But I think because on other ST Micro pinouts of the same exact processor, for some reason our PD 0 and 1 don't do anything when we use them in Arduino because the core is doing something funky with them. We need to use our internal oscillator because this product, this drum pad cleverly uses every single button. It uses every single pin, all 64 of them. There is not a spare pin on this entire chip. And that's typical of products. You know, they'll want to min-max the core to get exactly the right number of functions. And, you know, maybe you don't get an extra, you know, this is a weird reason is 13 keys on this thing, 13 drum pads. Probably went, well, if we use the 100 pin, we'll have too many extra pins and we'll have to spend all that extra money. So let's just have 13 pads and then we can fit everything else on this. There's a lot of weird considerations like that with products like this. So anyway, PD 0 and 1 for some reason don't work. We ran a command that remapped them, AFIO remap enable, AFIO mapper PD01 remap, right? Supposedly doing that releases PD 0 and 1 for our use. Now PD 0, or rather PD 2 is like way over here. It's pinned like 50 something. PD 2, it's like all the way over. One of these, like way over here. But it's still PD 2. Right here it is, right here. PD 2 is like way over here. The banks are weird on these chips. So they want to use for the 74HC 4051, the MUX, in order to connect six, seven, do your little stupid dance, to enable you to have 7 different analog knobs. They have one pin on the microcontroller reading all 7 using a MUX. The MUX uses a couple pins to set the address of the input. And so we're looking at these. These use PD 0, 1, and 2, which happen to be the subject of our weird pin assignment shuffling. So PD 0 and 1, we reassigned PD 1, and that fixed one of our pins, but it also made this one toggle high and not be in our control anymore. So if I do AFIO mapper PD 00, is that going to do anything? I don't know. This will probably kick it up in my face again. Let's just try. This has been very annoying, but we kind of got through it. All right, later, cuz. Got to get ready for work. Oh, man. That's a crazy... The time differences are so weird. You're a match. Oh, yeah, that was from earlier. Nope, it doesn't like it. Okay. Why don't you work? What we did is we assigned the pins to be 0, 0, 0. And when we have 0, 0, 0, we get the channel that 0, 1, 0 describes. Yeah, it's like Thursday over there. No, wait, it's Thursday here. It's like Saturday to them. Because 0, 1, 0 is channel 2. Channel 2 is E6. Our serial output, this is a lot harder than it needed to be, that's for sure. Our serial output is not E6, it's E5. What the it's E5. E5 is what we're in control of right now. E5 is 7. Wait, why is it 111? It should be 100. Or 110 is 7. Which is technically channel... Oh, no, that's 111. Right, so this channel goes to is 0 indexed. The 0 indexing is also throwing me off. So right now, we are looking at E5, right? E5 is connected to pin 4 of the MUX, which is channel 7. Channel 7 is 111. 0, 0, 0. Oh, is it inverted? Dun, dun, dun. It might be inverted. Let's check. Bum, bum, bum. Da, 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 dun, dun. Bum, bum. Bum, bum, bum. Da, 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 dun, dun. Do, 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 do. Mario castle theme. A being the least significant bit. If I set that to 0, this will not read any of the analogs. If we set that to a 0, meaning a 1, then it's 001 is the address that we're reading. And if we're reading 001, that's channel 1. Channel 1 reads E4. Please be the expected result. I could still have pins discombobulated. That's the problem. But this thing being inverted, I mean, I guess it makes sense. Everything on the logic control of this thing is inverted. So we have to set zeros in order for it to change the things. I don't know why. I don't know how that would invert internally versus the ones and the zeros that we see. I don't know, man. Okay, so reading 685 right now. If I go to E4, nothing. It's reading E1. Rat bastard. All right, E1 is what? We're reading E1, pin 5, or sorry, in-out number 5. Mambo number 5 is 101. So that actually needs to be in the middle. So if I swap A and B, it's either A and B or A and C. Let's do A and B. Let's try it. This will answer our question. So PD2, PD1, and we now know that our logic is inverted. So what's either going to happen is because right now we are on channel, what was it? It was oh, Jesus. We were reading 110. What the hell? Okay, hold on. I'm so confused. 110 read like 101. So technically this should fix it, unless my A and my C are swapped. In which case we would be reading 100. So if A and C are swapped, then we're going to get channel 4, which is E3. So my prediction is that E3 is going to be the knob that we get, instead of whichever is on channel 1, which is E4. So E3 and E4 determine whether or not we switch A and C. Holy crap, my brain hurts. This is logic puzzles, but where the cool little display of the different colored wires that you're supposed to connect together is in your head. Serial check. E3. It's E4. No, it's not. It's neither E3 or E4. What? What? No. You? No. You? No. Fader. It's the fader. It's the fader. It's the fader. Where's the fader connected? There could be a miswiring somewhere in here that I maybe got wrong. 6. It's on 6. Channel 6. Channel 6 is 110. 110, but that... There's no way it's CBA. Oh, my poor brain. Maybe I should map these out, and we'll just see which one is connected to what binary representation. And maybe then it'll be more evident what's going on. Let's just map it all out. It's only 8 channels, so we can see what the hell's going on with the pins here. So I'm going to start off and we will assume, do we assume that it's inverted or not? I don't see a reason why it would be inverted. It just goes through a resistor to the pin. Unless for some reason something in the core is reversing my numeric values. But we saw when we set them to ones that this pin had a voltage level on it. So I'm going to assume that we are not inverted. So 0 through whatever. Let me just do, I'll just write it down over here, and that way we can see what's going on. So right now we have 1 1 0 and we are on the fader. Which is actually, wait, we're not on the fader, are we? Hold on a minute. Oh, my brain hurts. I'm gonna write this all down first. Yeah, we're on the fader right now, which is not inverted. So channel 6, supposedly, fader. So let's make them all ones and we'll check out who's plugged into channel 7, which technically that would be 0, but maybe they're not inverted. Channel 6 news. Channel 5's live. Do. You know, I could just have it iterate through and tell us what the binary number is, or do that on individual numbers, or we got rid of the loops just to make things a little bit more direct. Okay, so 0 0 0 is fluttering between 20 and 19 is what it's doing. What? Oh, nobody. Yeah, so that's the disconnected channel. Somehow, in doing all of this, in thinking that it was inverted, our intrepid host has discovered that it's not. Oh no, it's 1 1 1 and I have nothing. So that's a big X. So under 1 1 1, nobody, I'm just going to double check. Nobody's input, which means it's 0 0 0. So it is inverted. Okay, okay, so we're not going to just assume that it's inverted. What I'll do is go, we're going down in numbers, so this is going to be 1 0 1, which would technically give us the 0 1 0, which would be channel 2. So if it is channel 2, then channel 2 is connected to E6. If I get E6, that means that A, B, and C are in the right order and they're inverted. This is taking forever just because the way we program this thing is time intensive. Nope, it's not channel 6. Channel 1, E1. E1 is the next one. This is just what we currently think is going on. It's like a brain-bending puzzle. Okay, so now we go to 1 0 0 in the order CBA. And it's inverted. Oh, no, we're not inverting them. We're just putting in what the numbers are. So CBA 1 0 0. Try that. See which one it is. This is killing me, man. I don't know if you guys can, hopefully you guys grasp how simple and how weirdly complicated this is. We were supposed to be throwing in button matrix code, which is fairly simple actually when you use the library for it. But we keep throwing stuff at this. So 1 0 0 is E3. Now, where would E3 come in? E3 on channel 1, which is 4, and 4 is correct. So that one actually is coming in on the right thing? Wait a minute. I wonder if that means B and C are swapped or something. Because that's non-inverted. That is in the correct location. Strange. I am so confused, you guys. So 0, 1, 1. Actually, 0... Yeah, 0, 1, 1. I don't know if this will run into the 0 port being open. I don't think I closed it. Maybe I did. Perhaps I did. So there's a couple possibilities here. I just want to get all of my data because none of my predictions were working. I want to get all the data. It's possible that we swapped a pin, or it's possible that these are inverted. So this would come in like 1, 0, 0. But every time I try to predict that, like if it's 1, 0, 0, then it would be channel 4, which is E3, but we just read E3 when it was 1, 0, 0. So if this is inverted, then it's 1, 0, 0, which is, oh no, that's channel 4. Wait a minute. If it is not inverted, then it's 0, 1, 1, and we're reading channel 3. And we should get E3. Let's see which one it is. It's E2. What the fuck? E2. Okay, E2. According to my schematic, E2 goes to channel 3. Oh, just like it is here. What? I actually only read 4, so E2. Yeah, that's correct. Okay. 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 So, assuming that I'm losing my mind, we go to 0, 1, 0. And that should read channel 2. Channel 2 should be E6. All the way down here. Now, it's possible that some of my E1s and 2s and 6, this is where we're swapped. That's possible. Some of the things I kind of eyeballed and put in logical order a little, and it seems like every time I do that, I get it wrong. So let's just see where we are with this. Nope, it's not. Yeah, it is. It's E2. Oh, it changed. My thumb. Ah, there we go. So that's E4. God damn it. Were my pinouts correct? E4 should be on channel 1. So that would mean that A and B are swapped. That actually may be the case. Let's just check the last one. So 001. Upload that. Oh man, and then I gotta look through the logic to see whether it's inverted wrong or pin swap. I think we tried every single order and my predictions were all completely wrong, so I don't know what the hell's going on here. Oh, and we still need to check 000. Okay. That's E5. We can see here, though, that we are getting unique values for everybody, and this is fully addressable. Like, that part's working. So our pins work, our inputs work, our analog read works, the assignments are off. It's like matrix algebra. You can swap the rows around. Whoa, what happened there? That was a weird one. Okay, start successful. That means that this is going to be E6. Yep, and it is. Oh no, that last one was, oh, I got my 5 and my 6 screwed up. That one's actually E5. The other part is that I'm getting stuff wrong. That's always a very real and distinct possibility. Okay, so given this information, the way that this should look, I'm going to give myself more space to work here. Having a master schematic document in MS Paint is not all it's cracked up to be. This is what I'm getting. This is what I should get. And it should be, here, just cut and paste that. Not connected, fader 132465. Here I'm getting 5 fader 1324 7654321. Okay, so that is in order. What would cause that order to change? And it's the ones and the zeros, obviously, if A and B are inverted or what. So if I'm channel 7, I should be getting E5 000. So that's an inversion on that. But because, you know, 000 and 111 are inverted, so those flop values, that's fine. For A and B to be inverted, if I am looking for channel 2, or rather channel 1, yeah, channel 1 here, 001 is 1. 001 should be channel 4, so B and A are inverted because 4 and 6 would swap. So B and A are inverted, which means 4 and 6 would swap. Hold on. That stays, and then 1 and the fader also swap, and then that puts everybody in the right order. And it's not inverted? No, that's not right. Wait a second. E5, and then it should go to the fader. So, okay, B and A, I'm going to swap in the code just so that what I have represents what's actually there. I'm going to do this one step at a time. So, B and A swap. B and A, where are we? Mux, where did you go? B and A, 1, 2. Okay, so having swapped those means that 5 and these two swap like that. Oh, we're not clear on the transparent selection. I wish I could permanently set that. Oh, and it looks like there's like weird white space around these, probably from the data sheet. Okay, so E4 and the crossfader E4, or no, not, sorry, crossfader. Well, E1 next to the fader. What the f? Okay, all right, getting there. If it's inverted, it should be in reverse order. So X going over to there. E4 should be here. The difference between those is 110 and 001. Do and do. No, that doesn't make any sense. I am confused. Maybe it's my pinout. Maybe I got these wrong. These are pretty easy to trace because it's like directly from the thing. The potentiometer just goes right to the 7400 series chip, and it's like real easy to follow. Maybe I just got those discombobulated a little bit. And I got to verify what I'm putting in there is what's actually happening. Pin 13 should be IO 0, and it should not go anywhere. And I think that's the case. But then, is there another, like, I'm just looking to see if there's like another bit swap that would put things back to where they are. It looks close to what, it's like E1 fade E5 instead of E3, but 0, 0, 0 versus 1, 0, 0. So going on this scheme, like, I think everything is recombobulated. It just doesn't match what I think the things should be. I want to verify the tracing of which ones here are connected where. I can do that pretty easily. It's got to be right. Okay, without removing too much, let's just get this out, flip it. Okay, so these are not labeled. So E1 and E2 are up here, and E1 is closer to the edge. So this one is E1, and E1 goes to pin 1, 2, 3, 4, 5. Pin 5, E1. That is what I've got in the notebook. All right. E2 goes to pin 9, 10, 11, 12. Pin 12. Sorry, that's E2. Yeah, E1, E2, pin 12. The rest of them go under, but you can see they've got a logical order to them. So 1, 2, E3. E3 goes around and under to this one, I'm assuming, which is 4. That says E5. Okay, so maybe that's wrong. 1, 2, that's 1, 2, 3, 4. So 3, E3, pin 1, 2, 3, 4. So actually I got an E3 over there, so I do have this wrong. Looks like E8. Hold on, I'm writing it down. That was E3. E4 comes under and around because, where is it? Around here. And what I'm assuming is the first of these. Actually, wait, I got that wrong. This is going to be the first of them. It's going to be the lower value. It's not going to be the higher value. That's not how that works. You fool, you fools, all of you. So E3 could potentially go either to pin 1 or pin 2. I have the crossfader going to pin 2. That's this line that goes up and out and goes way across the board. Yeah, so that's crossfader. And then 3 goes to 1. Crossfader probably 2. Because pin 13 is the no-go pin. Yeah, I think I got these right. I think I got them all where they're supposed to go. It's 5, 6. 6 comes up and around and goes as far down as it can to pin 15. So 16, 15. So that's right as high as it can because it's... No, that's wrong. Okay, yeah, so my pinouts are actually... This one's going to come in and it's going to go to the first pin that it can get to. So that should be 15, and that's E... 1, 2, 3, 4. E4. So actually, E4 and E6 are trading places. You know, it doesn't really matter that much as long as I just assign them properly. It doesn't matter what the 1s and 0s really are in the end. Just as long as I know where they go or what signal I'm getting from them. This detail is just weird. I don't really need it, but I want it so that I know what I'm doing. E6, E4, here and here. 6 and 4. Well, 1 and 2. That would flip them again, but that's not what we got. We got them inverted. But they were correct before. Looking at it again. It's just channel 0, for some reason we get E5. Is like one of the digits swapped? This is so weird. This is so weird. I'm really struggling with this, guys. Because E6 going to pin 15 would mean that... maybe that is correct. Hold on. E6, 15 goes up. Yeah, and over to E6. Okay, that's actually correct. E5 going to pin 4. 1, 2, 3, 4. Or it could go... well, no. 13? Maybe it does. Maybe E5 goes to 13, in which case 14, 13, that would make sense. So that means that we're almost correct. Because E5 is up here. So 5, 4, 6, 2, 3, and then fader and E1 are flipped. It's possible that when I put the 1s and 0s in there directly, I guess we'll cross fader on pin on a different pin. I mean, if they were on different pins, so E1, I mean, the crossfader is definitely going there. And then it would be pin 5 or pin 2. 1, 2, 3, 4, 5. E5 is definitely on pin 5. Yeah, that goes to E1. There's no... Remember, you've been moving those notes around. Yeah, I know. Well, okay, let's... I think we mostly have it, though, because, like, look at this. That's almost exactly it. Maybe I need to investigate the channel 5 and channel 6 just to see. I may need to move these, but I've already moved them once. Maybe I forgot to flip them. So let's check. We'll check channel 4 just as a sanity check, and then we'll check which one is the fader again. Because it seems like it's uninverted, and I just had E5 in the wrong place. This seems to be recombobulating in a way that it should. And I may have gotten my pinouts a little bit wrong. So let me plug this back in over here. When it comes to like the matrix keypad and stuff, that's going to be really easy to put in the code. We just need to put this in and crank the speed up, and then we can get a read on all the channels. So if I give it in order of CBA 110, I should get either E1 or the fader. And I won't mess around with the pinout again, because I think we're pretty close. Man, that was a whole bunch of bullshit. That was a whole bunch of bullshit, huh? One, 1, 0. So it's either going to be this or this, 5 or 6, depending on the pinout this time. Upload. My notes say the tested order was E5, E6, E4, E2, E3, E1, fader, nothing. So that would agree with the pinout. That would agree with the pinout that I got. Error, no debug probe detected. Oh, whoops. Plug it in, make it work. Go. Yeah, let's see what we got here. It's always human error, isn't it? Okay, so not the fader. That's E1. So 110 gives us E1. So it is actually, these two are swapped. It's pin 5 or pin 2. I wonder which one. Oops. Oh yeah, because we know it's definitely connected to E5. But if I, wait a minute. Because pin 5 we can just directly see. We just see it is definitely connected to 5 and not the fader. Unless something, no, nothing messed up is going on. We can see it as clean as day. It's just clear as day. It's just right there, right? So E5, E1 is definitely connected there. Why would, and then, okay, so if I got it wrong, or if I forgot to swap it, or whatever, this should be the actual order of things. So if I give it 101, wait. Hold on. I'm really confused, guys. Is this the fader? No, this is not the fader. This is E1 right now. So E1 on channel 5, but we had this in there. Oops, wait, no. Go back to 101, right? 101, channel 5. If it's channel 2, then it's inverted. And I just forgot. Did you change the Mux PDN mapping? I might have. I didn't change it this time. I hope I didn't just Control Z it away. I hit Control Z. I don't know how many times I hit it. Those Mux pins could have changed. Uh-oh. This sucks. I can't get anything right because I keep doing stuff. All right. It was almost exactly as I had it in the schematic, though. So I'm predicting that this is going to be... Okay, that's the fader. Fader on 101. That would mean that the two are out of order. But then if I send it 000, we get E5. Which would just mean that I guess my pinout is at fault. But this is so definitive. I don't know why I'm so messed up about this right now. I think it was 210. What am I doing? What am I doing? What am I doing? Oh my God. So we know if we send it all zeros, we get E5. What if I send it 100 from CB to A? Do we get E3? We just had that configured. I don't know what do we get. 101, we are getting the crossfader, which is mixed up, which may mean that I've accidentally flipped the pins. Do I need to just do, like, put a 1 in each position and just see where they land, and then I'll reconfigure A, B, and C depending on that? I don't know. Oh my God, my brain hurts. This is messing me up so bad. What I want to do is I want to be able to put a 100 into the values and see the channel that I have, just to know that everything is correct. This is very definitive. Pin 5 and pin, which one is it? Like 12 or whatever. One of them is like direct. It's like a direct connection, but I'm just continuously messing myself up in this. It's like 110 versus 101 for channel 6 and channel 5. Pin 2 is the crossfader. I mean, I can literally just use the multimeter to figure out which one is which too. in terms of pin 654321. Just to verify what's what. I want to make sure that what I have physically is exactly what's there. Multimeter. And then all the way over here, we've got the crossfader. So I can hook up to the crossfader, do a little ohm operation on that. I think it's this pin. Here, make sure you guys can see the multimeter. There you go. Oh, or is it? That's ground. This one to one of these. Nope. Which one is it? Well, I think it's coming in from over there, but it's which pin is the output of the fader? Crossfader. That was close. 400K is not quite it. Okay, check this bank. 400 ohms. Come on, man. This is not, none of this stuff is working. There you are. I found it. So 1.3 ohm to this pin. Yep, there we go. Okay, so there's the crossfader. So pin 2 is the crossfader. Okay, that's what we have on my schematic, and that's channel 6 for the crossfader. Okay. Pin 2, channel 6, crossfader. Got it. So then E1, double check, double check, double check, double check. E6 is the top right. This one over here is E6. E6, I have going to pin 15. Okay. It goes to pin 14. Okay, double check that I'm on pin 14. 16, 15, 14. Yeah, E6 goes to pin 14. So, stuff happening under the chip that I don't anticipate. E5, this one. Pin 13 is correct. Okay. E4 should be on 14 or 15. It's probably 15, 16, 15. Oh, no. Let me make sure I'm on the right pin. Okay, so E4 goes to 15. And E6 goes to 14. Okay, E5, 13, we already checked that one, didn't we? Oh no, the 6, 5, 4, E3 goes to pin 1. Is that legal? Correct. E2, we can see it's right there. 16, 15, 14, 13, 12. And then E1, we can see it's just right there. E1 goes to pin 5. Okay, so this is actually the order. Double checked. This is actually the order. So the ones and the zeros fade, E1, E3, E2, E4, E6. Watch. Wait a minute. And then 7 is not connected. Now I know I swapped these before, but with our pin assignments, that's what we were getting. Is this an audio IC? I wish. No, this is a mux, and we're just trying to reconcile what's connected to what with the mux, just so that my personal pinout, which is what we've drawn here, is the same as the actual pinout that we're sort of digitally accessing. But my notes have gotten discombobulated, and we've got to like, we're hardline programming it. We're doing very simple Arduino in order to figure out which one is which, and it's just been a trip. We've had to do all kinds of crazy stuff to get these pins specifically working as I/O, just because they are shared on a slightly different chip. They're shared with the clock, with the crystal clock. So now that we've gotten that done, I'm trying to get my ones and zeros in the right order so that I know what I'm actually putting into this thing and I can get a predictable output, but it's been messing me up. So presumably, according to the way things should be, if I give it 0, 0, 1, upload that. It takes a while each time too. I give it 001 CBA. I should have the knob E6 at my fingertips. Oh, no SMT32 found. STM32. Take that. It's all plugged in? Yeah. Try that. I got the serial port closed. Sometimes it gets confused when you leave it up. Close that. Yeah, that's what we're doing. No target found. What are you doing? What's going on here? COM8 is unplugged. Plug that out and in. Try it again. Yeah, there's no port, so that should do it. Oh, Big John's probably not here anymore. It's a funny coincidence that he finds himself in my chat today. No STM32 target. Uh-oh. Did I break it? Oh no, it's plugged in upside down. Ooh. I hope the programmer's okay with that. I hope I didn't just bust my chip by plugging this thing in upside down. Sometimes they'll do that to you, and it's like the worst thing ever. They'll have it so that when you plug it in backwards, it totally messes everything up and like blows up your chip. That's the worst. If STM32 is worth their weight, then hopefully this doesn't totally, completely break the board, plugging it in upside down. Oh no, it doesn't. I can see that the chip is working. If I hit a button, the button that I hit lights up. So, and that just successfully, oh yeah, no comment. I need to plug COM8 back in. Doink, there you go. And then if I open it up, we get, now the prediction was we're setting it to 001. 001 is E6. And I go to my serial port and I go to E6. Where's E6? It's right here. Nope. 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 There it is. That's E4. 001. So is B and A flipped? Boy, oh boy. B and A flipped. Let's see if we get E1 or fade by doing a 110. 1 1 0. Man, I'm being gaslit by my own program, you know? And that'll determine if B and A are flipped. I might have hit Control Z too many times and unflipped B and A when I flipped it. That may be the culprit here. I hate having to go, it's reverse engineering. You got to go back through stuff like 50 times. My dog will not let up barking at the door. I think she thinks the equivalent of her barking at the door is me yelling at the TV, at the computer monitors in here. Okay, so now we have fader or E1. It's E1. E1 is 101, and we program this thing to be 110. So A and B are flipped again. Oh my God, my brain. PD2 and PD1. So the order was 210 for anybody playing at home. So if I upload this, we will get channel 6 crossfader. Oh my God, Willow. She's like bark howling. She doesn't know how to howl. I tried to teach her how to howl. She doesn't know how to howl. What she does know how to do is go boo, woo, 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 woo. And that's sort of like her howl. And so that's what she's doing at the door right now. It's a little bit distracting. This should be the fader. It's the fader. Okay, we finally got it. We finally got there, chat. This took all day, but we can at least iterate through loops now and know what we're doing. So just as an academic exercise, I am going to set E2, 0, 1, 1. Down here. E2. Where's 0, 1, 1. E2. And at that point, I am calling it a day because I can't be asked to run back on all the stuff. We at least know what's there and we know how to control those pins. Those are the big ones. I will invent a loop in order to go through them so that we can do matrix stuff tomorrow. We'll do matrix keypad stuff tomorrow. And that should be easy. Those pinouts are definitive. So this should be E2. It's E2. Okay. All right, there we go. So we got there. We got there. We got there. So I need to reincorporate this. That's just going to make a big mash of all the numbers. Here, let's get in here. Alter my schematic. And then those pixels should match up. So we can just grab this right here. Drop it off in just the right spot so that it blends back in. There we go. And then this I can just throw to the side over here. This is our working document. A lot of information on this, but I can't get anywhere else. So Control S. It took some work, but we got there. Yeah, man, that was really annoying, wasn't it? It really should have come in a little bit more clearly. The second part of this is to test whether or not getting the stuff in this order is... Here, let's get rid of mux test on there and just do mux. Do mux is going to go through and use bit reads, possibly in the wrong order. Because what direction is that in? The 0th, the 1th, and the 2th bit. I think that's correct. What's up, Weaselbox and Adorphus and all you other people, all you other good people who are willing to watch a crazy person crunch numbers into their screen. We're going to do this without the delay at first, and we'll just see what all of these different inputs are. And we're going to print the number, and it's going to go 765432110. Our bit reads might be coming from the wrong locations, but I'm pretty sure least significant is 0. I'm pretty sure. So let's just try this and see what we get. I need to do a longer stream, but I need to take care of my dog too, so I probably need to take her for a walk soon. If she's freaking out at the door we've got maybe 20 minutes until I'll take her out for a little stroll. She's got her dinner up there. I don't know if she's eaten it yet. Hopefully she knows her dinner, as I was telling her. But okay, we're in. Well, bam. 7, 6, 5, 4, 3, 2, 1. I could space those a little better to look better, but channel 1. It seems like it's slow. And we're getting a similar read from all of them. No, wait. Oh, I see. So channel 7 and channel 1 are swapped. So yeah, we need to go the opposite direction. But that means that the crossfader is all the way at the end there. Nope. Crossfader is... Oh, the next channel. Okay. So that channel 6 is this. Actually, well, no. Channel 7 versus channel 1. It should actually be 0 indexed. So it's I-1. And it doesn't read channel 0. Knob len is... Right, the number of knobs that we have. Okay. And we're not delaying anywhere. And yet the reads seem... They seem separate and stable. And they go from 14 to 1,000, which is kind of a weird place to be. We will, of course, reconfigure them to be 0 to 255. It's weird that they got it to read down to 14, and they're all consistently... That one went down... Where's that one? Crossfader from 12 to 1002. Yeah, see, it's all within just a little bit of each other. But this is going in the wrong order, I think. No, that's the correct order. That's the correct order. Yeah, so it's dead channel fader, E1, E3, E2, E4, E6. They're just a weird order. So E5 is the one all the way at the end. That one's not adjusting. Hello? That's E6 all the way at the end. Where's E5? Oh, because maybe the indexing isn't getting it? One as E6. Is that off? Oh, let's get this out of the way. I want to be looking at my notes only. Oh, it's not reading channel 0. Okay. No, that should still be reading. I is greater than 0. It reads down to channel 1. Yeah, it's not reading the channels correctly. It should be starting at the length, and then what? It needs to go all the way down, and then... Okay, so my code is weird. My code is weird. Knob length, which is 7, so it should go down until I is greater than 0. If it hits 0, it stops, so it's never actually scanning channel 0. So it really should be... That would be channel 7 until I is greater than or equal to, but then it can't I minus minus. It'll loop around and go to the... if it's a UNT, it's going to loop around, and I'm looking for it to equal to 1. And so it would be knob length, since it really should only be reading 7 channels. What do I don't have like an extra channel in here. This behavior is weird. I am confused. Yeah, it's not right for 0 to 6. Yeah, maybe we should plus it. So I is equal to 0 as our first scan. And then as long as I is less than or equal to knob, what was that variable again? It was like knob len, like that, like goblin, but noblin, goblin, noblin. Yeah, so that'll scan all the channels properly, and they'll be in the right order. And then print line, knobs, etc. And then we're running it as fast as possible, as fast as serial runs, as software serial. But it appears to me that the values are stable. They're extremely stable. To the degree where I could say, if this value is what it was last time, don't send out a packet. That's how stable it is. Which I'm liking. I'm liking how stable all that stuff is. I don't know what they did in their electronics. I think it's the beauty of that resistor that they, or sorry, the capacitor they put on the thing. You want, oh, whoops, not greater than. I is greater than knob length. When did that change? I must have accidentally Control-Z'd it. I had it before, briefly. Oh, knob length 0. No. Try to get, you're going to give it an error and I've already corrected it. No. You bastard. What have you done? Okay. Knob len was not the, wait, there's a fucking, what's my variable? Lowercase knob. That's not a real variable. The case is different. Who in their right mind would be using different forms of capitalization to denote variables in their code? Those people are unhinged and they should be removed from society. The capitalization should not be as revered as it is in programming. Oh, that's not that variable. You capitalize that one, then that's the right variable. That would be the most cursed code. If all of my variables were the same word, they just have a different capitalization to denote between the variables. Okay, I guess we're starting from -1. But that is E5, as it should be. I need to redo the numbering scheme. I think I had a -1 in there. We're just I now. We're not I -1. I have to re-upload it. It has to be right. I have to get it right. I got to get it right. Otherwise, what do we have? We have nothing. We use I++s to make this stupid dumb baby code and iterate through all of our stuff properly in a way that a first-year programming student could read. And now, if I go to the fader, it's all the way up at the last channel like it is in the real thing. So the order of operations, check it. What's that in the array? Oh, yeah. Oops, we'd be getting the wrong variables too. Oh my goodness. All right, upload that. Now we're all recombobulated. Everybody's doing what they should. And I can run through the order of these things and we can get values moving where they should be moving. And we're scanning this thing as fast as we can. The CD4017 is, 4051 is fast. It is fast. What do they say for their settling time? Yoink. I don't know. It's in here somewhere. I think it might be waveform channel being turned on, waveform channel being turned off, turn off time, turn on time. We're talking about 10 nanoseconds. Oh, you guys, no, you can see that. I just have MS Paint on the other window. Yeah. All right, so boom. And no, it's still wrong. Channel 6. Oh, it's still getting to channel 7 because I gave it 7 locations, including channel 0. So actually the I-1s were not incorrect. The I-1s were to re-index, or it should be I+1 for, no, hold on, wait a sec. What is my problem here? 0 index 7 channels, channel 7 doesn't do anything. So it'd be knob length -1 right here, because it's 0 indexed. But then to print it, we have non-0 indexed, so that it shows channel 6 through 0. That's not correct. Wait a minute. Hold on. Hold on a second. We start at index 0. We go until knob length -1. Yeah, because we're starting at index 0. Yes. Okay, and then when we print it out, we can keep it on I just because the 0 indexed is how the data sheet displays all the channels. 0 indexing will cause you so many problems, and I am most of them. Wait, this is still 0 indexed. No. We're gonna have to wait for it to fully upload. No, wait, no, we re-indexed it. It's fine, this is fine. No, we don't need to, okay. 0 indexed on the count of positions for the array. We re-index it. We're not actually re-indexing it. It's still, no. Yeah, we're re-indexing it here. And then we're stopping the count at the appropriate spot. Okay, I'm sorry. I'm not an expert. I'm not an expert. I'm just doing this stuff. I'm just the one at the helm. I'm not the one who knows things. I think I got it though. 0 indexing messes me up in every way. So we have from 0 to channel 6, but why is channel 6 a 0? That's the fader. E1. So wait, how would we be missing a channel? Because we get up to 6, less than or equal to, knob length minus 1, so that equals 6. And then we send it the bits, and then we analog read that value and we print it back out. Knobs of I minus 1. Oh. There it is. That's the one chat was trying to tell me about. I don't like to read chat when I'm programming just for those kinds of errors. I know. You guys are invested and you're trying to like steer me in the right direction. Those kinds of frustrating things are going to happen. They're going to keep happening. And I am going to allow them to happen so that you guys can see what happens in typical programming. I like things to be real. I don't necessarily like to have the chat IDE always correcting me and steering me in the right direction. So now the fader is the last entry, and we can see that changing the values there. And so I'll go in order of what we've jotted down today. This is a massive amount of organization. So it's fader E1. So that's E. Well, let's turn them all down. Everybody down to 0. Everyone down to the lowest value. That's the highest value. I went the wrong direction. They're all fade up is a larger number than fade down. Okay, so we're looking for that line to basically expand visually. And so if I do the fader, boom, that line expands. If I do E1, channel 5 E1, channel 5. Next one is E3, channel 4, confirmed. E2, channel 3, channel 2 is E4. Channel 2 is E4, confirmed. Channel 1 is E6, confirmed. And then the last one, channel 0, is E5. We got there, everybody. Thanks for being patient with me. We got there. And with no delays, these values are super stable. Can I get us... Yeah, the most we get is a single-digit deviation. 6, 7, 6, 7, 6, 7, you can see rolling by. I didn't purposely choose the meme number. I have to tell you, that meme sucks. Code 67 in that particular precinct of Philadelphia is, I believe it's like a one of the homicide codes, because the rapper that did it was about hopping on the freeway to the next exit to avoid, while hearing the 6-7 being called off of the person that they shot. That's not why the meme sucks. The meme sucks because 6 and 7 are sequential numbers. They're in line with one another. So if you're like, wow, I see that number everywhere, you need to to just get on a bus, just get on a yellow bus, wherever they let you off, find a math teacher and just start learning, please. Because 6-7 is going to be fucking everywhere. 69 is no stranger to that closeness of numbers, but it's still a little bit more rare than 6 followed by 7. And so when I go and I do something in electronics and I have like a number on screen, setting it to be fluttering between 6 and 7 is a natural thing that happens, and it's not necessarily intentional. But look at how stable that is on our serial reads. Now, this is slower than it probably would be reading internally in the microcontroller, but I mean, those are locked in, man. We're scanning pretty quickly through these, and they are just locked. So what I think can happen is, without too much alteration, I can look to see if a number is equal to more than 2 numbers deviated from where it was before. So we'll just take the number out of the array, and we'll add 1 and subtract 1, and we'll just make sure that our new value is between those before we write a new one. Which could mean, well, no, it'll still write the value once for any sort of travel situation. That's really cool. So now we've got all these available to us. The next step is to get the matrix running, and by that I don't mean like, you know, Neo, all that stuff. I mean like the matrix, like as in, that's what, why is all this shit on screen? Okay, matrix as in a button matrix. Button matrix saves you pins by having your microcontroller pull rows and columns. So we can activate a column and look to see if a row is active or not. I kind of want to use a library to do this because while it is easy enough for me to just count through this and set like a pin address to the 1s and 0s here, right? I don't want to go through all that work. We could just put in a library and just have it do it quickly. I was somehow 25 minutes behind. How does that happen? I've had actually some pretty big numbers like that before too, where things just like don't progress. Now, if I hit one of the pad buttons, it'll throw in the pad value too. Everything is on demand. So I will have to put in a compare loop. Right there. That'll look at the previous value versus whatever I've got in the analog read. So that's going to need a different reading. Knobs of I is equal to, so that's going to need its own conditioning in there. That's basically how I'm going to do it. I'm going to do an if loop, and if value is above or below thingy, then it'll put it into the knobs of I, and then I can also have it serial printed at that point. Stuff print knob space stuff print I stuff print colon space stuff print line of knobs of I. So if mux read is greater than, or is it, if knobs of I plus 2 is greater than mux read, or is this one, knobs of I minus 2 is less than mux read. So if knobs of I plus 2 is greater than mux read, or knobs of I minus 2 is less than mux read, you can mix farts on that. Ah! That's high. What? So the original value plus 2 is less than the new value. If it's plus 2 is greater than, if plus 2 is less than the value, or if the original read minus 2 is greater than, no. I think my order is weird. I don't, hold on, wait a second. The original value plus 2, that means it's above, minus 2 is greater than, if that value is above the new value, I don't know. I just confused myself again. We don't need this print line down here. I think this is how it works. Let's check. That'll possibly make it very weird. It just means that the pads and the numbers are all going to be independent of one another. Now I could do just a regular greater than or less than, but if it gets in one of those modes where it's like toggled a little funny, then it's not going to be having a good time. So expected, I forgot punctuation. That should do it. Building it like this means that built into this whole thing is a way for this thing to go to sleep and not constantly hammer the CAN bus with messages. We're gonna have to be careful about that. What did I do? What did I do? What did I do? Double equals. How'd that get in there? Technically, the compiling should be getting faster as we do it because it knows that it doesn't need to totally recompile huge amounts of code. Well, knob 4 seems to... See, there goes knob 2 a little bit. I think I've got my orders wrong. I think I got it in the wrong direction. Sometimes it works. Yeah, okay. We read the mux, and it is more than 2 from the original, from the last value that we put in there. What up, 3D Printer Shack? Maybe it just needs to be 1, plus minus 1. But if we... Oh, knobs of I plus 1, knobs of I in the previous... Yeah, minus 1. Plus 1 and minus 1 outside of it like that. Is that logic the correct direction? If the read is greater than... If the read is much less than... If the read is greater than... Okay, I think that's correct. I think that's correct. The alligator is facing the larger number. Go, go, go. That gives us a little wiggle room for things to kind of sit still. It's the most rudimentary way to do that. Nobody said anything? Move a knob? Yeah. And then it stops when I stop. Yeah. Oh, that's cool. That's fun. I had a boss tell me about one device that he made that was this big, it's like a microcontroller thing. It was a big bank of sounds in the thing. So there were hundreds and hundreds of sounds that you could, sound banks that you could scroll through. And he actually made a system of, like, basically he put frustration into a variable. And the reason that he did that was so that it could scroll faster and faster. It didn't just scroll faster and faster over time. When you flick the knob, there's a certain amount of regrip time that it takes you to go grab the knob again and flick it again. So the faster the flick is, and the amount of time between flicks would speed you up in scrolling through the sound bank. I think he got it to be pretty stable, but it was just funny because it's literally like a user frustration timer. This just kind of reminded me about that. Down to 14, all the way up to 999, sometimes 1,000, depending on where you are. So 1,000, 14, and the values are so stable that when I take my fingers off of it, it stops serial printing. That's cool. All right, we're making progress, everybody. All right, I want to thank everybody for coming out, witnessing me futz around with the microcontroller, gaslight myself through code, think I'm crazy for a little while, regain my consciousness and firm grasp on what is real and what is fake, and figured it out. We finally have it characterized. I can access whichever on the mux I need to. I have the microcontroller flipping through mux channels. All of our pins work. That was a big one. That was a weird one. All the pins didn't work because on the typical blue pill, this thing, which has a different pin out, it's got a different number of pins, but the pins that are associated with those pins, the pin banks that are associated with those pins, are not used on the oscillator. But because we did some stuff with this to use the internal oscillator, those oscillator pins that are assigned to the wrong pins, because Blue Pill, ST Micro probably didn't put all that much work. I mean, they put a lot of work into making the Blue Pill. I just don't think, I think the pinout that we're using is more rare, so they probably didn't reassign what was being. Anyway, the point is, we were able to reactivate those pins using kind of obscure code. It was a weird thing. And just for the sake of records, what we did, we invoked AFIO remap enable on AFIO mapper PD01. So for some reason that got both of those pins running again. So once we got both of those pins running again, we were able to characterize our pin reads so that I can throw an iterating variable at this thing. And so if I turn a knob and the value changes, we've got them all on the right thing. Now I didn't put in a variable that tells you which knob it is. I could probably do that, but see, I'm hitting pad 7, pad 9, and then if I move the knob, knob 2, knob 3. Cool. We're almost there. We got to do the matrix and then we do the encoder. And the matrix, the button matrix, these 8 buttons here, those are pretty easy to get. Don't you call me a knob. You get banned. No, you guys are allowed to call me a knob all day. That's what this channel's all about. And I'll own up to it too sometimes. But we got to do a matrix for these buttons, and then we got to do an AB encoder for the encoder. And so in the same style, we will have this thing scanning the inputs, and if they are appreciably enough different, then we will have it output something in the serial print. Then all we have to do is make it so that instead of serial print, it sends it over the CANbus. And that's our device. That's it. So it's looking pretty good. Yeah, this is like the worst tutorial. Absolutely bullshit tutorial. I spent most of this time counting numbers. Remember, I put Livestream in the YouTube title for that very reason, so people don't accidentally interpret this as being some type of tutorial on how to do these things. That's fine. I have 0 viewers on YouTube. It's showing, usually you count as a viewer, it should be 1, but it says right there, it says concurrent viewers 0. Is this the beginning of the end, chat? You motherfuckers. Okay, well, anyway, I'm going to be back tomorrow. Maybe we'll get a viewer. Maybe not. It's fine. It doesn't matter. It doesn't matter. Doesn't matter. I gotta go walk my doggy, my very cute corgi, who probably should be in every single thumbnail. I should exploit the ever-loving crap out of that dog and just put her picture on everything. But I'm gonna go take her for a walk because she's very cute. And then I'll be back tomorrow. In the meantime, you guys can catch me on Discord. This is inaccurate. I'm gonna be streaming tomorrow. I'm just gonna use the end card just so that I have at least have the Discord link up on the doodle. Not the doobly-doo. Stop saying that. I hate that. I actually really dislike doobly-doo as a phrase. Discord is the only one that works. My Blue Sky got hacked and fucking banned. So I got to figure out how to get that back sometime at some point. Anyway, very successful day. Thank you guys so much. I should take my girlfriend for a walk too. She is cute. Sorry, I restructured your sentence there because my brain doesn't work this far into stream. This has been a particularly confusing stream, so I will see you next time, and maybe it will be a little less confusing to just throw a couple Arduino libraries at this thing and have it work. I'll catch you guys then. What button? Where's the stop? I keep hearing this tapping noise.